for people to join.
All right, and we are live. I am Wyatt, and I'm joined here today by Michael Leff.
Hello.
Today is our Programming Essentials workshop. So we're going to go through the basics of setting up a programming environment to code some Python in, and teach you the essentials of taking input, producing output, and how to think about some simple problems. So you might have seen from 7 to 8 o'clock tonight, this workshop will solely be doing Python stuff. But if you stick around for the 8 o'clock to 9 o'clock portion, we'll be going through some C++ stuff. Now, this workshop is targeted towards people who have like next to no competitive programming experience and maybe even like next to no like regular programming experience. So we want this to be really beginner friendly. So if you have any questions at any point, don't hesitate to throw them into the chat and we'll do our best to help you out. So to get started with Python, we're going to need to get Python installed on our computer. Now, if you don't want to install Python on your computer, there's sites online such as REPL. So let me pull this up quickly. You can go to this site called repl.it, and this is what you do Python or C++ just in browser. But really, if you're going to be doing more of this in the future, I highly recommend you install Python on your own machine. So to do that, what we're going to do is we're going to open up a new tab, just search for Python, and this is going to take us to the official Python homepage. Now, this is going to differ a bit depending on what operating system you're on. So right now, I'm on Windows. So if you're on Windows, all you need to do is go to Downloads and go Download for Windows right here. If you're on Macintosh, I believe the process is similar. However, if you're on Linux, like if you're on Ubuntu, for example, then you'll want to install the Python package. So on Ubuntu, the command for that would be sudo apt-get install Python. But really, you should just look up how to install Python on whatever Linux operating system you're on, if you happen to be on one of those. But I'll just be walking through the windows with you here today. So as you can see, we got the Python installer, and we clicked on it, and it's opened up this little wizard that'll take us through the installation process. So to start, you'll notice there's this thing here that says add Python 3.8 to path. And I'm going to recommend that you enable this. What this does is it makes it so you can run Python from the command line, which ends up being pretty convenient. So we'll click that, and we'll just click to install the regular installation. Now, I do want to point out, so I'm showing you how to install Python, just like the official Python from the official site, and we'll be doing our coding today for Python in this thing called idle, which comes by default with Python. But many people are quite fond of Visual Studio Code instead. So if you want, you can also get this Python set up like directly in Visual Studio Code. And we won't be walking through that, but that's something a lot of people find convenient. Actually, Michael, what do you do your Python in? I'm curious.
I just write everything in Visual Studio Code. I just run it in terminal.
It is really convenient. Yes.
Right now you're doing this for Windows. If I had a MacBook, how would I do this?
So MacBook, I was a little hesitant because technically you should be able to install packages on your MacBook as well. I don't know the exact command off the top of my head, but if you look up like install Python on like a Mac, you'll find like whatever command it is. Now I assume there's even like a non-command way of doing it where you actually just like similarly download an installer, but I don't know it off the top of my head. But it's very, very Googleable, as are many things for this stuff.
Yeah, I remember idle, the good old days. Wyatt, first year.
Oh yeah.
Idle was our go-to, man.
Yeah, when I first started competitive programming, I did everything in idle. Honestly, there's nothing wrong with it. It has everything you need to do like basic Python programming. It has the interpreter. It has like a nice little editor. It has syntax highlighting. So I don't know why my installation is taking so long. I did a few sample runs of this before the stream, and it was actually quite fast.
It's installing a whole test suite.
Yeah. Ooh.
Don't you miss Python 2? It was
Oh,
not
yes.
like this. More light.
So what Michael is mentioning, so there used to be a Python 2, and Python 2 is like really famous and widely used, but recently it was actually end of life, like I think like a year or two ago. So now it's like there's like no support for Python 2. It should be bad if you use it, but despite that, it's still used pretty widely in industry. But
Mm. Wait,
there aren't too many like noticeable differences between Python 2 and Python 3. It's mostly just how you take input, and about a few things like range and map behave a bit differently.
hmm. Damn, it's installing a lot.
Yeah, I don't know. So I don't know why it's just taking so long. So if
TCL, TTX
if for
support.
some reason this is taking even longer on your machine, you might want to try out REPL, which I had here. If you want to do REPL, you can just say start coding and then select some programming language. And like I guess here you'd want to select Python. And it'll set you up like a small little environment where you can program Python. Oh, actually, I wonder if my downloads are slower since I'm streaming. I don't know
Oh,
if
it's
that's how that
installing.
works.
It's already downloaded, right? It's just installing. Just running it to your.
Oh, yeah, sorry, you're right. I don't know why it's taking that long then. In any case, we'll wait for that. Almost there. Sorry for making everybody wait this long. Yes, hopefully these slow download speeds don't continue because we'll be downloading what is it, Windows Subsystem for Linux in the C++ portion of this tutorial, and that'll take quite a bit longer. All right, almost there. Right at the end.
It's like a good chunk of this just watching you install
Yeah, I'm
things.
gonna watch install. Yeah, if you're watching the recording of this in the future, feel free to like skim past this part at super speed.
Yeah. Do you just wanna just move on or something, or you wanna?
Or we're pretty close. So yeah, I'm so tempted since it's like nearly there. I have faith in my Python installation. Um, but yeah, honestly, we can move on. It's taking too long. Let's put this to the side. Let's open up our REPL. Okay. So this is still going. Yeah. Okay. So the first thing I wanted us to try out in Python is just printing to output. So the sort of like most popular thing to do when you're starting to learn a programming language is to print hello world. So we can go here and go, oh, if I can spell, go hello world and press this run button up here. And this will call the Python interpreter to run on our code. So just to talk a little bit about that, something that's interesting about Python compared to something like, let's say, C++, is that something like C++ compiles down to machine code, which is like, it's like a language like the computer can actually like understand and run directly, versus Python is really just like, if you write a Python file, it's just a text file, and this text file gets interpreted by a Python interpreter that knows how to run the different Python instructions on the machine. So this is how we can print hello world, so that's nifty. And you'll see we can actually have more of these print statements. So if we wanted, we could do something like print A, print B, print C. And you'll notice here, when we run this, we get A on one line, B on another line, and C on another line. So there's kind of two things to note here. One, notice that things print in the same order here as in the order that we've written them in our Python file. That's because what the Python interpreter does here is it goes through our file line by line and tries to run each line of code. So first we'll look at this first line and say, oh, here it wants me to print A, so I print A. Then I'll go, oh, here it wants me to print B, so I'll print B. Here it wants me to print C, so I'll print C. The other thing I should talk about is that for some reason, we put in these quotation marks around this thing we want to print. And you might ask, well, like, why do we do that? That seems kind of like random. So the reason for that, in programming languages, when we work with text, we normally call that text a string and enclose it in quotation marks like we've done here. Now, the reason why we need strings is the programming language needs to be able to distinguish between like symbols in the language, like let's say like print, and strings. Like for example, I could print the string print, and the program would need to be able to distinguish between this print, which is a programming identifier, and this print, which is like a string. So here, like for example, we're printing print, which is fun. So Python's also kind of a weird language in that you can use double quotes or single quotes. Both will work just fine.
They do that in a lot of languages, though, right?
Really?
JavaScript has that.
JavaScript, that C++ is not. It's not of that. So be careful not to get burnt by that.
People use backticks too.
Backticks. Oh, backticks are weird. Can you do that in Python? Is that allowed?
No, I think. Maybe.
Let's do this. This is not going to work. Don't try this at home, kids. Yeah, this is. You can already see this is the syntax.
You can do that in JavaScript. JavaScript lets you do many things.
Yeah, so this is a good learning lesson. So if you do something that's not allowed, you'll get a warning from Python saying like, hey, I don't understand what you're doing. And that warning will normally point you towards your error and tell you what it doesn't understand. So here we have a syntax error because we did something that wasn't allowed. Okay, so what we've learned so far is that we have a program, we can run our program with Python, and it goes through line by line and tries to run every line. So sometimes we want our program to ignore some lines. Like maybe we have some documentation, like, hey, I'm documentation. Or maybe we have some code that we don't want to run right now. We just want to turn it off for now, and we'll maybe turn it on later. So if you start a line in a Python file with this hashtag symbol, then that tells the Python interpreter that this is a comment, and it should ignore everything else in the line. So here on the second line, I have a hashtag, so the Python interpreter will completely ignore this text. Similarly here, even though this is like a Python code, it'll be completely ignored because I've commented out. And you'll see this happen. Sorry, you'll see that if we run this, only this first print prints because everything else is commented out. So the main use for this is you can add comments to help other developers read your code. So you can say things like, maybe I'm gonna do a print down here, like print hi, and then I'll add a nice comment to help someone reading my code and say, this is a line that prints hi. So that's sort of the main use case for comments. All right. Now, let's say I've got a bit of a forced example here. Let's say we want to say hello to a lot of things. So I want to go hello cat, print hello dog, print hello moose. So I could do this, and I could type out hello all these times, but it was kind of a lot of work to type out hello all these times. Like I had to type the exact same thing. And one thing we tend to really hate in programming is redundancy. So what we can do is use something called a variable to store things that we use all the time. So here, for this hello, I could say, I can make a new variable. So to make a new variable in Python, you just type any word. I believe, I forget the exact thing. I believe it can't start with a number, but let's say I'll type this word, I'll say H. Now you can call it whatever you want. I'll call it like H. You can even do like a single letter if you want. And in it, I'll store this hello. So remember, we call this thing a string, and it's just how we store text in a Python program. And now what I can do that's really funky is I can say print H plus cat, H plus moose. Sorry, H plus dog and H plus moose. Now, what do you guys think is going to happen here? So if you think about it, so this thing is a string, and it looks like we're trying to add this string to another string. So what does Python do when we do that? Let's run and find out. Oh, so it looks like Python just sticks the strings together when we try and add them. So here, we've added the string hello to the string cat, and we'll get hello cat as one word. So for my hellos, I don't want these to be one word. So I'm going to add a space at the end of my hello. And now when I run this, I'll have a space in my hello cat, hello dog, hello moose. Now, we might run into a scenario where, just HCAT, I like that comment. We might run into a scenario where we want to change our variable. So let's say that I want to do this exact same thing, but instead of saying hello, I want to say hello, hello. So I'll say it twice. So then maybe I could go h equals hello, hello, and I'll do the same print afterwards. And you'll see in this new section, we'll use hello, hello instead of our regular hello. And that's because we've changed our variable. So instead of storing a value of hello, it's now stored a value of hello, hello. Now, another thing we should try is, what happens if we try and do this, but we actually forgot to put a value in our variable, so we didn't set it up or anything? If we try and do that, we will get an error saying, hey, we don't know what h is because you haven't defined it yet. And so that means we need to store something in h first. So we saw that we could have a variable, which we called h, and we could store a string in it. But it turns out Python actually supports like a bunch of other data types that we can store. So this thing that we've already done is called a string. But we also have integers, which are just they are like integer numbers that you might have seen in class. So like 1, 2, 3, 4, 5, 6, and so on. And also negative integers. So -1, -2, -3, and of course 0. So like that's a valid integer, that's a valid integer, that's a valid integer. And we can actually print an integer just like we would print a string by going print and then specifying that integer. So you see here, if I print a, since a has a value of 1, we'll print 1 here. So another data type that Python has is a floating point number. So that name sounds kind of weird, like floating point, like what's going on there. But you could think of a floating point numbers as being like decimal numbers, like decimal point numbers. And the floating point actually refers to like the decimal point. So if I want to store like 1.5, for example, this would be a floating point number. And we can print it just like we print any other number in Python. So if here I can go print b, and it prints out. Nice. All right. All right. So I'm trying to think what other. Oh yeah, sorry. The other probably most important type you should know about are Boolean types. So Boolean's a weird. It's like a special type. It can only store 2 values, and those values are true and false. And we can print these just like how we would print any other type. So you see here I'm printing C, which is equal to true, and it just prints true to the screen. And so those are pretty much those are the main variables you'll have to deal with right away. We'll deal with a few more complex things later, but this is really all you need to know to get started. All right. So with that in mind, let's make a bit more of an interesting program. My goal is right now, I want to write a program that takes someone's name as input and says hello. So the first thing we're going to need for this is we're going to need a way for our program to take input. So in Python 3, how we do that is we call the input function. So how this input function works is we can call it by typing input and these 2 parentheses. And that tells Python hey, I want to get some input. And that'll prompt us on the screen for some input. And then we can provide some, and the result will be stored in this variable for later. So much in the same way as we stored the string hello in the variable earlier, we can store an arbitrary string that the user gives us and use it in our code. So here, let's store some string s and then print it back out. So here, if we run this, I can put in some input. So if I put in the word cat, then my program is going to print out cat right back at us. So we said we wanted to make a program that says hello. So let's say input. And another thing, I guess some people don't know about this, but it's very handy. In input, you can provide it with 1 argument. So input's a function. And to provide arguments to a function, you can just put things inside these parentheses. So input takes 1 argument, which is the string we want to, a string we want to prompt the user with. So if I go input and I say, please type your name, that will prompt their user to type their name on the screen. And then we can print out their name, and let's print out hello, their name. So we'll say hello to whatever name gets typed. So let's try this out and think about what happens. So here, if we run this, we say, please type your name. My name is Wyatt, so we'll type that in. And our program will say, hello, Wyatt, because hello. So Wyatt will have been stored in this variable s. And then we do hello plus s, which becomes hello plus Wyatt. We get the string hello, Wyatt, and that gets printed to the screen. Okay. So with that in mind, let's make our program a little more interesting. Let's say, imagine we had a program where we wanted to say hello to everyone except Bob. We really hate this guy named Bob. So let's have it say hello. Ready? Unless the name is Bob, in which case let's say go away. Okay. So we really hate this Bob guy for some reason. So what we can do here is we've stored a string, which is going to be their name, and we need some way of checking to see if the name is Bob, and running some code if that's true, and running some other code if that's false. And so most programming languages, including Python, have something called an if statement to deal with this. So the syntax for that is we can go if this name is equal to, and that means check against Bob, then we want to do something. Otherwise, we want to do something else. So now, if their name was Bob, we'd run the code in here. And if their name wasn't Bob, we'd run the code in here. So let's add our code from earlier. So if their name isn't Bob, we'll say hello. And if their name, is Bob, we'll say go away, Bob. Okay. And let's try that out. So here, if I enter my name as Wyatt, again, we just get hello, Wyatt back. So that's super simple. But if I enter my name as Bob, so let's run this again, then I'll get go away, Bob back, because we don't like Bob for some reason. So this is how you do an if statement. All right. Now, you might have already guessed this, but since we have integers and floating points, we can actually do all sorts of math in Python. And if you're just trying out math stuff in the Python, I often find it really handy to try things out in the interpreter. So what I mean when I say interpreter is this thing right here will just run Python code. It's like this section on the left is our script, which we can run, and it runs the whole script. But this section on the right is our interpreter, which we can just run code in arbitrarily. So you'll see if you put a number in Python, it gives us the number back. But if we do some math on the number, Python will actually do that math for us. So we can do like addition, we can do subtraction, you can do multiplication. Well, that's not really exciting multiplication. Let's do this. Okay, that's better. We can do division. And yeah, so you can do all your basic math in here, which is really handy. We can also do a thing. This is pretty handy. Sometimes in Python, you'll want to do division and just like round down to the number below. So for things like that, like let's say I do, what's a good example? Let's say I do 10 divided by 3. So this is like 3.333 something. But let's say I wanted to round that down. There's two really easy ways to do that in Python. One way is we can take 10 divided by 3 and cast it to an int. So this int here is actually just a regular Python function. And if I call this int function and provide it with 10 over 3, it gives me a new int object that just like chops off any non-integer part. Or another way I can accomplish this is by doing truncating division. So this is a special kind of division in Python that just ignores all decimal points. So here, if I do two slashes, that's how you tell Python you want to do like truncating division. So you see here, this also just returns 3.
So Wyatt, you know how this rounds down the float?
Yes.
I always wonder like what's the best way to round up the float.
Round up. Oh, there's a good way actually,
So
I
if we
believe.
do 10 divided by 3, I want the 3. I want the 4. I want to round up.
Okay,
What's your technique for this?
let's consider that on the fly. So technically, if you do have a float like this, there's a built-in thing you can use. So you can say from math import ceiling. That's actually like the most like standard way of doing it. You can do 10 divided by 3, like that. The other thing you could do is you could make your own sketchy ceiling. So you could do something like, instead of doing 10 divided by 3, I could do what? 10 plus, I think, yeah, 10 plus 2 divided by 3.
10 plus 2.
So the idea here is, this is actually kind of complicated, so don't be like stressed out if you guys don't understand this. But the idea here would be, if 10 divided 3 evenly, then this 2 wouldn't have any effect, since it's not a full 3. But if this 10 didn't divide 3 evenly, then this would bring us up to the next number. So you see here we get 4.
That's good. So it would be like if we're dividing by like some number n, we always do a plus n minus 1.
Yeah, exactly. So yeah, if we're going like, let's say we're going like n equals 3, if I want to go 10 divided by n and ceiling it, and I don't want to use math.ceiling for some reason, then I would just do 10 plus d minus 1 divided by d.
Okay.
Yeah.
So that's
Okay.
better, right? Because we can use that in any language.
Yeah, so why Michael's bringing this up is that in a language like C++, all division is actually this, all division on integers is actually this truncating division, which means that you have to do a trick like this if you want to round up. So knowing how to do this sort of thing is really useful.
Yeah. But so the addition method, right? If we did in another language like C++, then there could be like an overflow issue too, right?
Yeah, so you have to watch out for that. Yeah, sorry, that's another good point. So another really awesome thing about Python, and why I think it's especially great for starting out, is integers in Python can be arbitrarily big. So if I go 10 to the 100 in Python, or 10 to 1000 even, sorry, it gives me this giant integer that's absolutely huge. In most programming languages, they can't actually store an integer this big. It would like give you an exception. Sorry, it wouldn't even give you an exception. It would just overflow internally and like silently give you an error, which is awful. It's not something you want. So Python's really nice, and it'll let you work with big integers. But do beware that the bigger your integers get, the more time and like work it takes to do operations on them. So be careful about letting your integers get too big. Oh, and I see a good comment in the chat from Blake. He says, oh, I guess he already answered his own question. But he wondered if we could do something like 10 divided by 3 plus 1. And then that works for this, but yeah, as you mentioned, this sort of thing would fail if we divide evenly, because then if we have 9 divided by 3 and we want to round it up, the correct answer to that is still 3. But if we do this, we'll get 4.
Okay. So can you do the 9 with your equation, see what comes out? The 9.
Oh, yeah, it'll work. So
2.
consider if we do 9 plus 2, right? Mm-hmm. It brings us to 11.
Yeah.
Which will still be 3.
Ooh. And then don't do the double, do the single division. It would have like 3 point something, right? And
you wouldn't do this plus 2 thing if you're doing single division. You would just do like regular division. Yeah. Okay. So we're already through like half my content. So
I just jump one more thing.
Yeah, yes,
it was just because the double division thing isn't available in like C++, right? Or
yeah. Oh, sorry, in C++,
it's like a Python thing.
Yeah, in C++, yeah, if you're doing work on integers, you can't do this double division thing unless you like actually explicitly cast it to a double. Sorry. Also, for any of our audience who is new and who's thinking right now, like what the hell is a double? Like, what are you talking about? So typically, so those floating point numbers we talked about earlier, like let's say f equals 1.5. These are often called floats or doubles. Typically, the reason why something would be called a double is that it's just a float that has twice the precision, hence double. That's how it's got its sort of like weird name. Yeah, but sorry, what were you saying?
I was just saying, so basically when you do that double division, it does an automatic cast to an int for you, right? So in C++, you would have to do 9 plus 2 divide by 3 and then cast it to an int.
Oh, sorry, no. So
it's all one line, right?
So sorry, in C++, if you did 9 plus 2 divided by 3, 9, 2, and 3 are all integers, so your result's already going to be an integer.
Oh, okay.
Yeah.
But what if I'm storing in a float? So I do like float f equals 9
Sure.
plus 2 divided by 3.
So if you're doing a float, then you wouldn't do it. You wouldn't do this. You'd actually use like a ceiling function.
Okay. Okay.
Yeah. Okay. Okay, yeah, so the next thing I want to take a look at is something called a for loop. So what this does is sometimes you want to do something a lot of times in Python. And to control how many times you do something, you use a loop. So let's say we want to print hi 10 times. We could do something like for I in range 10, print hi. So how this works here is we can specify a number here, which is the number of iterations we want to do if we're just doing range 10. And it'll print out, so it'll run our inner loop contents that number of times. So here we're going to run this 10 times. So we'll just get hi 10 times. And now what's really cool about this is, so this is the syntax for a for loop in Python. It actually will assign this I to every value starting at 0 that's less than 10. So if I print hi and then I here, and you'll notice I'm doing a comma here. If you want to print like a string and an integer on the same line in Python, you could do like plus string of I, which would cast the integer to a string. But that's kind of inconvenient. So what's easier is the print function is pretty smart, and it will let you just provide multiple things you want to print as extra parameters. So here I'm providing I as a second parameter, and so it will print hi and I. So if I do this, you'll see it's going to print hi 0, hi 1, hi 2, hi 3, hi 4, so on, all the way to hi 9. And I want to provide a bit more context on why this works. So it turns out that this range right here is actually a function you can call in Python. So if I just call range here, it's going to return some like weird like range objects that I can't really do anything with. But if we convert that to something called a list, which we'll talk about later, but for now just think of list as something that expands out all the elements. But if I convert something to a list here, you'll see that this range really represents all the numbers from 0 to 9. So all Python's doing here is it's looking through every element in this like sequence of items and assigning I to that element. So if you do range 10, then I gets assigned to 0, then to 1, then to 2, then to 3, then to 4, all the way up to 9. So we can actually do this a bit more generally then. So if I can go for I in range, let's still go 3 to 7. So what this will do is it'll print out 3, 4, 5, and 6. And so the idea here is this first number we specify in range is the first number, like the number we want to start at. And this number here is the number we want to, the first number we want to not use. So, I'll say that again. This is the first number we want. This is the first number we don't want. And we count up by 1. And so we can make this like larger too. So if we make this like 15, now I count all the way up to 15 starting at 3. Up to but not including 15. So the last one we do is 14. Now, you should also know, instead of having a step size of 1 here, you can specify a third argument in range that'll change the step size. So I can specify a 2 here, and the step size would become 2. So then I'd go like 3, 5, 7, 9, and so on. And this can be like pretty handy. So as a fun sort of use case for these for loops, I've got a small thing I want us to program. I want us to try, what is it? Let's read in, let's say, 10 integers. It's actually 10's a lot. Let's read in 5 integers and sum them. Right? So what we can do here, there's a few things we have to figure out. First, we have to figure out, so we're going to be summing a bunch of values. So we need some sort of thing to store the final sum of our values in. So to do that, let's make a variable. I'm going to call it result, and I'm going to set it to 0 to start. And the idea is, as we go through our integers, I'm going to add those integers to this result variable. And we haven't talked that much about variables, even though we talked about them a little bit earlier. But you can always just think of a variable as like a store of value. So it can store some value, like so right now this stores 0, and we're able to like read that value later and like update it. So for example, I can increment it by like, I can say like result equals result plus 1, and that would cause it to increase by 1. So actually, yeah, let me actually do this quickly in the terminal over here. So if I made a variable, I'm lazy, so instead of result, I'll just use r. I can make a variable r, and if I go r equals r plus 1, then you'll see my new value of r is 1. And the reason for that is here, it reads in the old value of r is 0, it adds 1 to it, which gives us 1, and then our new value is 1, which is what's printed out here. So because it would kind of suck to type this whole thing out every time, Python also provides a shorthand where we can go r plus equals a value. Like here, instead of 1, I'll do 2. I can do r plus equals 2, and now the new value of my r will be 3, since 1 plus 2 is 3. So it just increments r by that amount. And like in the same way that we have plus equals, we also have minus equals, times equals, and even divide equals.
Is there a mod equals?
I don't know. Let's try. So r is this. Oh, I mean r afloat. Wait. Let's say r equals 5. Oh, to be fair, Michael, I don't think we've explained mod yet. There was one math operator we didn't explain earlier that's pretty useful. So that's called the modulo operator, which is this thing. And how it works is it gives you the remainder when you do division. So for example, I do 10 mod 3. Oh, sorry, that's the wrong symbol. 10 mod 3. You'll see our remainder is 1. Since we can go 3, 6, 9, and we'll have 1 left over. Similarly then, 11 mod 3 will have a remainder of 2, since there's 2 left over. And 12 mod 3 will have a remainder of 0, since 12 evenly divides 3. So a really common usage for that is we can check if a number is even by going, let's say I've got some number n, and I'll go like n equals 8. I can do something like if n mod 2 equals 0. So if a number evenly divides 2, then we know that it's even. So we can do something like print even. And here we print even. Oh, except this is REPL and it's weird. Let me do this here.
Maybe just print it in normal.
Yeah, sorry.
I think you had an extra space on that print.
Yeah, that's probably it. Okay, so we can do that. Why isn't that? Oh, it's time to define n. Okay. Cool, so here we see if n is 8, then n is even, since 8's an even number. You'll also notice we did this weird thing here where we did 2 equal signs. So I want to quickly talk about the difference between 1 equal sign and 2 equal signs. So when you're using 1 equal sign, what you do is you put a variable on the left side and some value on the right side, and it assigns that value to the variable. So this is something we call assignment. Now, on the other hand, this double equals is a check. It's like a check in your program that checks to see if these things are the same. And it returns true or false. So if I go, for example, 1 equals 1, we know that 1 is equal to 1. So this will return true. But if I try to do something like 1 equals 2, that would give us false. Now, similarly, we can also do things like less than, or even like less than or equal to, and greater than or equal to. So those are worth knowing. Okay, sorry, so we got somewhat off track there. So our original problem we wanted to solve was to read in 5 integers and sum them up. So let's try that quickly. So here I can make a variable that I call result. I set it to 0. Now, since I'm making a program to read in 5 integers, let's make a loop that goes 5 times. Sorry, that iterates 5 times. I in range 5. Actually, I should say yeah. So I said the word iterates there, which is like a weird programming word. Iterates is like whenever this inner part of your loop runs, we call that like iterating, and we call it one particular run the iteration. So if we have a loop that runs 5 times like this, we'll say that it iterates 5 times. That's like the fancy lingo. So here, let's see what we want to do. We have to read in 5 ints and sum them. So it looks like in the inside of our loop, we're going to need to read in an integer. So if you remember from earlier, we can take input by going input. And then I guess if we have an integer, and I'm going to intentionally make a mistake here for fun. If I have an integer, I should just be able to add that to my results. And then if I print the result, I should get my total. Now, what do you think about this program, Michael?
Oh, it's very nice. Very good program.
Very good program? Well, unfortunately, it's going to give us an error. Let's see. Oh, sorry, we have to give input. So if I do 1, boom, right away we get an input, and it says, oh god, like what is this? Unsupported operator types for plus
Oh,
equals
right.
int and a
Python
string.
3.
Yeah. So let's quickly go through this error. So first, we see this thing as a type error. Now, what that means is, so you remember earlier that our variables had something we call types. So we had, like, for example, we could have a variable that's stored an integer. So this would be something of integer type, versus we could have something that's stored a floating point. So this would have like a floating point type, or we could have something that stores like text, like words and stuff, which we call a string. So this has like a string type. So it turns out in Python, if you want to add two things, they normally have to be of the same type. Now you can override that in some cases if you make like your own custom classes and stuff. But if you want to add, like, let's say like an integer to something, then the other thing should be an integer. So here then what we need to do is this input that we got from the user is still a string. So what we're going to do is we're going to call the integer function on that string. And what it will do is it will take in this string and convert it to an integer. So I'll even just like kind of highlight that here. So if I call this like this input function, and I give it a number like 1, 2, 3, 4, what we're left with is the string containing the digits 1, 2, 3, 4. So this is still considered to be text, not an integer. But if we then call the integer function on it, it'll be converted to an actual integer. So that's exactly what we do here. We take input, we cast it to an integer, and then that result is stored in X. We add that result to our total, and then finally at the end of the day, we print out the sum of our numbers. So let's try that. So let's add the numbers 1 plus 2 plus 3. How about this? Plus 2 plus 1. So this should sum to, let's see, 9. Let's see if we get that answer. Cool, and we do get 9. So that's a good sign. All right, so that's how we do a simple for loop. Now, it turns out if you want a bit more control, in Python, you can also do a while loop. So how a while loop works is it goes while some condition is true, and I'll leave this blank for now, but while some condition is true, we do run your code. So what we could do here is we could handle this loop variable ourselves. So let's make we can make an I equals 0, and we could go, well, this I is less than 5, I want to run my code, and then at the end of each iteration, increase I by 1. So let's think about just what this code, like right here, would do. So to start, I would be 0. We'll reach this line and say, is I less than 5? Well, let's see. 0 is less than 5? Yes. So we go in here, we'd run our code, and then we'd increment I by 1. So I would become 1. Then on our next iteration, so that we go back to the start of the while loop here, we say, is 1 less than 5? And it would be yes. So we'd run our code and increment it again to 2. And so this would continue on until eventually I would be 5. And we'd go, is 5 less than 5? And that would be false. And we'd run the rest of our code. So what we're going to do here is I'm going to take our code that we used from the for loop. I'm just going to copy and paste that into here. And we should be able to run that and get our result. Let's see. Oh, sorry, we have to type in numbers again. Let's do the same numbers, just for the sake of clarity. Yes, and we get our same result. So this shows you how you can like manually have a loop of your own. Nice. Okay. So now a really important topic that I briefly mentioned earlier, but we really haven't gone into any depth on, is something called lists. So often in programming, you want to store a sequence of like items or a sequence of variables, effectively. So what you do to do that is you use something called a list. And to make a new list in Python, we just make a new variable and assign it to 2 empty square braces. So by default, our list, if we do this, will be empty, so it contains nothing. Now, a list in Python supports this operator called append. So we can call .append on the list and give it some item, and that item will go on our list. So here you see I've placed an integer 1 onto the back of my list. And if I do this again, let's say I append it 2, you see it once again goes on to the back of my list. So if I do this a few more times, I might end up with a bunch of things on my list, and I want to figure out how many things I actually have on my list. So to do that, I can do length of my list, which will return the number of items on that list. which is like pretty handy. So, sorry. So those are two important things to know. So how to append to a list and how to check its length. But probably the most important thing about with lists is knowing how to index into them. So lists support this thing called the get item or square bracket operator. And what that does is you specify this thing called an index, and it returns the value at that index. So if you're new to this, you're probably asking, like, what is this index thing like? So it turns out this index is the offset of the element you're interested in from the first element. So if we go offset 0, that'll take us right to the start of our list. But conversely, let's say if I did offset 2, that would take me to 2 elements away from the start of my list. So here, imagine we're on the first element. If we go offset 1, it brings us here. And with offset 2, that brings us here to this 3. So A at 2 then will be 3. So this is kind of handy because if we're in Python and we have a list like this, we can actually go through the elements in our list. So imagine if we do for I in range length of A, we can go print 8i. So this allows us to do things like this that print all the elements in our array. So let's think for a second why this actually works. So here we have a list that has 4 elements in it. When we call length of A, it returns 4. So then range of 4, if we like iterate through range of 4, it's going to iterate through the elements, 0, 1, 2, 3. And then if we go array at 0, we get our first element. Array at 1, we get our second element. Array at 2, we get this guy. And array at 3, we get our final guy. And I guess to prove that, if we print out I as well, you'll see that I goes from 0 to 3, where 8i goes from 1 to 4. Now, this is kind of a hassle to type. So in Python, there's actually a shorthand for doing something like this. You can go let's go for E in A, and this will just iterate through all the elements in A in order and assign them to E. So now I can just go print E, and this will just print out the elements 1, 2, 3, 4 in that order, just like we're used to. So this is really handy. Okay, so I only have 2 more topics left for my Python. One is functions. So do you have a favorite example for functions, Michael?
Fibonacci.
Fibonacci? I was actually thinking that. Okay, so yeah, so functions are really useful when you have lots of code you want to run over and over again, or when you have code that needs to, like, I guess, a call itself, which won't really make sense until we tell you what a function is. So actually, yeah, let's do a simple function first. So let's do a function called say hello. So to make a function in Python, we write the word def. So this is just like the syntax for defining a function. We write the name of our function, which can be like any name we want. And then here we put in any parameters the function will take. And we can name these whatever we want. So let's say this function says hello to a name. So let's have it just take in one variable called name. And now let's have our function do print hello name. So our function will just say hello to whatever name we give it. And then I could do, get ready for this, say hello, let's say Wyatt, and it would say hello to that name. So what happens here? So up here, we're defining the function. So when you're defining a function, it's just like setting aside some code so it can be called later. It's saying like, hey, here's some useful code. If you call say hello later, I will run this code. And then later we can call say hello by saying the word say hello, which is its name, doing 2 parentheses and putting in any parameters that we want. So here I provided 1 parameter, which is this name, and we use that name to say hello to something. So now it's cool. What's cool is if I want to say hello to a bunch of people, I don't have to duplicate the rest of my code. I can just go like, hello Wyatt, hello Michael, hello Lucas. Oh, yeah, and we'll just do all that.
Cool.
Nice. So as a bit more of an exciting example, you may have heard about the Fibonacci sequence before. So the Fibonacci sequence is a sequence, and it goes 1, 1, 2, 3, 5, 8, 13, 18, 13, 21, and so on. And the idea is the sequence starts with 1, 1, and then for any element later in the sequence, it's created by summing the previous two elements. So 1 plus 1 gives us 2, 1 plus 2 gives us 3, 2 plus 3 gives us 5, and so on. So this is kind of fun. We're going to write a function that calculates the nth Fibonacci. So let's call our function fib, and it's going to take in n, which is the Fibonacci number we care about. So let's see. So right away, we know that if let's like zero index the sequence. So what I mean by that is, let's say that this is the 0th Fibonacci number, this is the first Fibonacci number, this is the second Fibonacci number, and so on. So I'll list that indexing underneath. So we can see right away that if we want the 0th or the first, or I guess, sorry, the 0th or the 1th element in our Fibonacci sequence, those are both going to just be 1. So let's hard code that case. So in our function, if n, which is the Fibonacci number we want, is equal to 0, or n is equal to 1, then we can just hard code our result for that and say return, return 1. Now you're probably asking too, like, what is this return thing? So the idea is when you have a function, I'm going to comment this out quickly just so we can show a concept. When you have a function, like let's say I make a boring function called def x, and it just returns x plus 1. So it turns out that a function can actually return a new modified value. So here this simple function f takes in a value and returns a new value with 1 added to it. So if I go f at 3, and now let's say I run this code, we'll see that we get 4 printed out. And what happened here was we passed in 3 to our function. Our function took 3, added 1 to it, so it got 4. And that value gets returned back to us, and it gets used in the print. So this whole expression here, this whole function call expression, will evaluate to this return value. So with that in mind, let's keep working on our Fibonacci. So we can see if we called Fibonacci with n equals 0 or 1, we can just return 1. Now, otherwise, if we didn't return 1 here, then we need to calculate Fibonacci by summing up Fibonacci at n minus 1 plus Fibonacci at n minus 2. And this is actually all we need to do to solve Fibonacci. So, yeah.
Sorry to jump in. Yeah, this question actually gets asked in interviews. So you can, they'll ask you to write like the simple form first.
Yeah.
And then the optimized form. So
yeah, so I should point out too, don't write it like this in an interview, because this is really, really inefficient. So it's actually good from a competitive programming point of view. Implementing it like this can take up to an exponential number of function calls. Since, let's say I try and calculate Fibonacci at like 5, let's say, that will result in calls to like Fibonacci at 3 plus, sorry, I should say Fibonacci at 4 plus Fibonacci at 3. And each of these will result in 2 function calls. So then I'll have 4 function calls, then I'll have 8 function calls, then I'll have like 16 function calls, and it gets really, really awful really, really quickly. So there's much better ways of calculating Fibonacci where you only use 2 elements at a time. And there's other things you can do. There's a technique that it's covered. We'll cover it at a future date. We definitely won't cover it in this. But there's a technique you can do called memoization, where you memorize answers. So, for example, if I had calculated Fibonacci 4 once, I could just use my old memorized answer, and I wouldn't have to calculate it twice. So that's like an advanced DP technique. But we'll cover that later. That's really handy. And by later, I don't mean today. Another technique is there's a super advanced technique where you can calculate high Fibonacci numbers using a matrix and exponentiation by squaring. So that's a fun thing to Google if you really like math, but definitely also not worth covering today. And there's also a way you can just calculate a Fibonacci value directly using the golden rule. But once again, that's just like a math thing. That's not really programming. But it's if you're in an interview, those are good things to know for Fibonacci. Not to beat it to death. All right, but let's test this out. Let's see if this actually works. So let's run this. So we've ran it. Now let's try calling Fibonacci. So if I call Fibonacci at 1, I get 1. Okay, that's a good sign. Fibonacci at 0, I get 1, good. Fibonacci at 2, we get 2, nice. And so if you're thinking about, once again, why this works, if we make a call to Fibonacci at 2, then internally it's calling Fibonacci at 1 and Fibonacci at 0, and it's adding the results together. And so this is how you can make a basic recursive function. So that's handy to know.
If Fibonacci at 500.
So this will start to time out very quickly. I don't think we can do 500. Let's see. It'll probably start to lag even if I do. Let's see how long it takes this thing to lag. So if we do fib 20, still good. If we do fib 50, already at fib 50, it looks like we're dying. It doesn't help. The numbers themselves also get very large, so you're kind of dying from all angles. So I'm gonna control C that.
Kill it, or is it?
I just killed it, yeah. So we can get out of that. All right. So now, since we got through all of that, I'm going to teach you, I guess it's like a black arts, secret, an underground programming trick. I'm going to teach you the easiest way to read in a list of inputs in a competitive programming problem. So often in competitive programming problems, you get things that look like this. You get problems that look like this. They'll say, given an integer n on one line, followed by another line containing n space separated integers, and they'll have you do something. So this is probably the most common input you'll get in competitive programming. So it's really handy to know how to read this in easily. So to explain this again, like the input you're going to get is going to look like, on the first line they'll give you some integers, so like they might give you like 5, let's say, and on the next line they'll give you 5 integers, like they might give you something like this. So this is what the input will look like to your program. And so to read this in, what we can do is, first we want to read an n, which will be on the first line. So we can say n equals input, and this will give us a string. So let's cast that to an int. And the next thing we want to do is we want to read in the array that's on the second line. Now reading in the array is kind of hard. There's like a really sneaky way that I'm going to do it, but I'm going to break it up step by step so it actually makes sense. So
well, I can give an example in the comments of what the input would look like. So
yeah,
like
that's
one
a good
number.
idea. So like here, this is going to be numbers. This might just be 5. But for our actual reading in the array part, it might be like 5 integers like this.
Yeah, so you're passing in 2 lines.
Yeah, so we can do this over here as well. So let's say, for example, I did n equals int of input. It'll prompt me for input. And if I enter 5, it'll take in 5 and cast it to an integer. So now we have 5 as an int. Oh, sorry. So I see a message from Allah. He's asking if this is going to be uploaded. This will be uploaded on the channel later. So feel free to like view this like on your own time afterwards at your own pace.
Mm-hmm.
I want to point out too. I was going to say this a bit later, but I should mention it now too. Like I'm doing a super like race car like speed through overview of the useful stuff in Python that you use in competitive programming. But this is like a pretty awful way to learn if you have no experience before. I'm going to post a link to the tutorials point at the end of this presentation. And you know what? I'll even do that right now, just in case people have to go. And if you look at this tutorials point, it walks through all the Python syntax, and it honestly only takes like an hour or so to walk through all of this. So I highly recommend just doing that if you have the time. Okay, cool. But so onto this exciting part. We want to read in an array like this. So to start out, we could just read in the array as a string. So let's consider doing that. So I'll take input. And let's say I specify my array, just like how it would be specified to our program. And you'll see we get this string that contains our integers and contains some spaces. So that's not really that useful for us because there's spaces and they're not even like integers, so we can't do math on them. So luckily, Python has this built-in thing called .split. And what .split does is it takes a string and splits it on spaces. So if I call a.split, it'll actually give me this list of strings where it just split up my initial string on these space characters. So now I can modify my first line to a equals input.split. And that'll give me that, then if I run that and give some input, that'll give me my input with splits into a bunch of strings. Now this still honestly isn't great because each one of our elements in our list is now a string. And I can't do like integer math, like I can't add or divide really like strings, at least not the way I'd want to. So what we need to do is convert each of these to an integer. So I'm going to show a really awkward way of doing that first, and then I'm going to show a nice way. So imagine we use what we've done so far. So I read an input, I split it on the spaces, and what I can do now is I can do for I in range n.
Oh, why? Just a heads up, it's 8 o'clock, so...
Yeah, so we're going, I think we're probably going to end up going a bit over time. Originally, our C++ session was supposed to start at this time, so if you're here for C++, no, it's probably going to be delayed, probably about 10, I would say like 10 to 15 minutes while we finish up Python, since there's some things we should still go through. But yeah, so sorry if you're a C++ person coming in, like do bear with us, or like, get yourself like a snack or something, I guess. Anyway, sorry. So here we've written our input and we've got it like this. And if we wanted to, we could iterate through. Yes, sorry. The C++ session will also be uploaded. It'll all be uploaded as like one like big video, and I'll put in a few links so people can know where like the start of Python is and start of C++ is. Yeah.
Okay. Are we just gonna do a HackerRank question together for Python? Okay.
Oh, wait, for Python, yeah, we'll do like two, maybe like 2 HackerRank questions. But first, we have to finish off this like crazy input thing. So one way we could convert all these strings in our list into integers is to literally iterate through the array and say each element of my array is now going to be set to that same element cast to an int. And we'll see that if we do that, we do get a list of integers, which is nice, but we have to write a lot of code to do that. So let's make sure that actually works first, though. So here I can type 1, 2, 3, 4, 5, and we have an error. Oh, sorry, it's because we're also reading an n still. So we have to do give n, which is 5, and go 1, 2, 3, 4, 5. We read in our input, and look, we've casted them all to integers, so it's really handy to work with. So this is great. But it kind of sucks because we had to write all this code.
Yeah.
So instead, what we can do, and it's a lot less code, is we can say, instead of these 2 lines, we can say a equals list map int a. Now this looks absolutely terrifying. It's like, what is this doing? So what this is doing is there's this fancy built-in function in Python called a map, and how it works is you give it a function as the first parameter and a list as the second parameter, and what it does is it goes through every element in this list and it applies this function to it. So right now it'll go through all the strings in our list and convert them all to integers, which is really handy. And then finally we cast that to a list just because this map object is something that's called like a lazy object. And what I mean by lazy is it doesn't do any work until you actually request an item. So if we convert it to a list, it'll request all the items and just give us a regular list. So if you're interested in learning more about that, I highly recommend you look up something called a Python generator. But that's a bit beyond the scope of this thing. So for now, we'll just cast this to a list and assume that's the good thing to do. So let's try this out. So here we've tried mapping all the values to integers. And let's see if that works. So we can go here, 5, 1, 2, 3, 4, 5. And whoa, cool. So they all get cast. It's nice and easy. And now you'll notice instead of doing this on 2 lines, I could really just take this input.split and copy and paste it and put it right inside where a was here. And now I've turned this into a one-liner. So now this is a scary looking one-liner, but this will read an array of input and convert it all into integers without you doing any any painful work in Python. So this is probably the most useful line probably from this presentation. Like I use this in pretty much every contest for whenever I have to read an array of input.
Yeah, that one line you're going to use basically every single time.
Yeah, so this is super handy. Make sure you understand how this works. It's super useful.
Yeah, I have to get a picture of that one.
Yeah.
That's a really useful.
Comment. Super useful. This one.
You want to jump into a HackerRank question?
Yeah.
Just like a lot of people came for the C++ thing.
Yeah, sorry. Okay, so we're going to do some really easy C++ questions to start.
Python questions?
Yeah, all in Python. Oh, sorry. Really easy Python questions. Thank you. So for this first question, called a simple array sum, we see the input looks a lot like that sample input we were doing. We're given an integer n, which is the size of our array, and then we're given n elements. Seriously, I'm going to zoom in a bit so you guys can see better too. So yeah, so in this question, we're given n, which corresponds to the number of elements in our array, and then we're given like n space-separated elements. And it seems like in this question, it's pretty easy. It just wants us to take the sum of these elements. So what we can do here, oh, I already have the answer here. Ignore that. Is I can go n equals int inputs dot split, and then I can go array equals n. I hope you guys remember the line. This is our line. We're gonna go list map int input dot split. It's a mouthful, but it works.
Yo, what? You have a dot split on the n.
Oh, sorry. Yeah, the first one shouldn't be a split since there's only one element we're reading in. That's a good catch, Michael. And now we need to find the sum. So we could just make a result variable and look through all the elements in the array and add them to our result. And we like print that out. And this will work. You can see we can run this. If I go down here, so that works. But it actually turns out there's an even easier way to do this in Python. In Python, there's a built-in method called sum, and it will actually sum up all the values in a list. So if I call sum on A, that'll already just like sum up all the values and give me my answer. So that's super handy. So we can try that. And ready, we'll run. And boom, we get the answer. You can submit it here. And just like that, we're good. Okay, nice. So let's do one more Python problem. This one's going to be a little bit more fun.
You can compress that one too, right? Just do just print the sum of the list of the map.
Oh yeah.
You don't need to start with the A. Just call sum of that.
Yeah, you could do all of this on like 2 lines if you really wanted, but that might be too much for me. Okay. So next problem is a problem called staircase. Now I'm sure Michael will recognize this problem. So the idea here is you're given an integer n.
Oh.
And you want to print this staircase shape of size n. So we want like sort of like 1 step here, then 2 steps on the next line, then 3 steps on the next line, all the way up to like n steps on the final line. So if we think about this, let's think about this problem. So here, I hope you can all see my Jamboard. Oh, this is loading. Okay, so in this problem, we're given some integer n, and this is like the number of steps.
Mm-hmm.
And so, for example, if n is 1, then we just have 1 step. Instead of drawing hashtags, I'll just draw dots since I'm in a not great drawing application. Now, if we had n equals 2, we would have 1 step on the top, followed by 2 steps. And if n equals 3, we would have 1 at the top, followed by 2, followed by 3. Okay, so then thinking about how to solve this, what we can think of doing is, intuitively, our answer always seems to be like almost in like a box shape. It's like half of a box. So we can imagine drawing a box. I'll show the n equals 3 case. You can imagine drawing a box around our output. And then in this box, you'll notice that on our first line, we do n minus 1 spaces, and then 1 dot.
Mm-hmm.
And then on our next one, we do like n minus 2 spaces, and then 1 dot, and so on. So you can almost think of like, since this thing has width of n, we do n minus 1 spaces on our first try, and then our number of spaces just decreases by 1 every time. So you could do logic like that to figure out how many spaces you need and how many dots you need. Since we know, so our spaces starts at n minus 1 and decreases by 1 every time, and our dots starts at 1 and increases by 1 every time.
So this is an example where n equals 3, right?
Yes, but we can scale this up like arbitrarily.
Yeah, so the dimension of the box is always going to be n by n.
Yeah.
Okay.
So let's try that out. So the input for this problem is really easy. Oh, also, see, I'm deleting the HackRank input. This is generally good practice. The input HackRank gives you can often be quite bad. You're normally better off just getting rid of it. All right, so let's read an n. Now, we notice that the number of levels in our staircase is going to be equal to n. So we have like n steps. So let's make a loop that goes n times. Okay, and then at every level in our loop, let's see, we wanted to print, actually, let's not even consider every level, let's consider our first level. In our first level of our loop, we wanted to print, let's say we wanted to print n-1 spaces, and then a hashtag. Now you'll notice here I'm doing a string times a number, and that seems kind of weird. It turns out in Python, it supports some really weird syntax, where you can do like a string, like if I do a string like this, like cat, times a number, and it will just concatenate the string that number of times. So here, if I do a space times n-1, it'll give me n-1 spaces. And then I want like this hash line at the end. Now this would be good for our first level, but I want this to work for every level. So what else do we know? We know for later levels, we know our spaces goes down by 1, and our dots goes up by 1. So then we also know our I here starts at 0, and then in every subsequent iteration, it goes up by 1. So what we could do is we have n-1 minus I spaces, and 1 plus I of these hash symbols. So if you think about it then, on our first iteration, we'll have n-1 spaces, and then it will decrease to be 1 less the next iteration, and 1 less even the iteration after that, and so on. And similarly here, we start off with 1 hashtag, then it goes up to 2 the next time, and so on. And so this forms like one big string for the current level, and we can just print that for every level, and we'll form our staircase. So let's see if this works. Okay, cool. And we get the desired output, and we can even submit that. And if we submit that, we should hopefully pass all the test cases. Moment of truth.
Yeah, no, yes.
It's not loading.
No.
so HackerRank's kind of buggy.
Oh, HackerRank.
Yeah, actually, I was gonna point to. Oh my god, did it even submit?
That's your submissions.
Okay.
Oh no, that was the old. Oh yeah.
It hasn't done it yet. Wait.
Oh,
wait, accepted. Very good. Okay, cool. So I want to point out, just for anyone, because like I know plenty of you have probably heard about like LeetCode and HackerRank and all these sites, and you might wonder like what you should actually use. So I'd like to say, HackerRank is like basically like a dumpster fire. It's not really that great. So for competitive, so if you want to do this sort of stuff, if you're solely focused on interview prep, I recommend doing LeetCode, because that has like actual questions to be asked on an interview. So that's the site you should be looking at for these things.
Yeah.
And if you actually want to do competitive programming, like, and you're interested in like maybe like the big contest we do is something called ICPC. If you're really interested in that, you should be doing code forces.
So if you want jobs, just play around with LeetCode.
Yeah, jobs, do this one.
If you want to just have fun, do code forces.
Yeah.
Taking every live stream, we always roast HackerRank. Like
it's true.
I feel
it's an awful site. It's an awful system.
It's just the only site we use is HackerRank.
Yeah, it's pretty bad. It's because it's so accessible, so we still use it, but it's not great.
Oh, so funny.
Okay, yeah. So that's just good for everyone to know. All right. Do I have any more content?
C++ time?
Yeah, C++ time. I think that's everything. I'm curious, did my Python ever finish installing? My Python didn't eventually finish installing. So I guess 10-second thing for people who are still in the Python. Once your Python is installed, you can just run idle, and it will give you like a terminal, just like the terminal on REPL that you can use.
Yeah. So with C++, do you still want to go like on the same level as Python? So like with Python, you talk about like all the variable types and all that stuff. Are you still gonna do that with C++?
Oh, I think so. But especially, and the one thing we really have to do is like in Python, we have lists, which are really nice to work with. But the equivalent of lists in C++ is something called a vector, and it's a lot less nice to work with. So we definitely have to talk about that. Okay. Oh, but sorry, yeah. Here's like, this is what your idle would give you. This is like a terminal where you can do Python in. Oh god, what did I do there? Sorry. This is a terminal you can do Python in. And you could like make a new file by going file new, and then you can like write Python code here and save it. So if you got that set up, you can do that there. But we're going to focus on C++ now. Oh yeah, CPP time. I see our Ori supporter is here and knows it's CPP time. Yeah, you missed. Ori and I had like a wild live stream. Michael.
Oh, Ori? Ori's on the live stream?
Okay. What am I saying? Oh yeah, okay. So for getting C++ installed, I'm going to start the installation, but then I'm going to encourage you to do it on your own because it takes a long time to install, and we're probably just going to do it here on REPL since that's pretty convenient.
Yeah, so, I'm just going to throw all the links in chat that you're using.
So first off, I find the most convenient way to do C++ on Windows is to use something called the Windows subsystem for Linux. This effectively lets you like have a little Ubuntu terminal while you're still inside of Windows. So it's like the most convenient thing. So if you want to install that, you can just Google like install Windows subsystem for Linux. Yeah, Michael's like already got it there. It looks like it'll take you like right here, and yeah, there's all sorts of ways you can make this really fancy. But if you just want to try like having this run right now, you can run this PowerShell command in your PowerShell terminal, and then you can just go to the Windows Store after you've run that command. Oh, sorry, Windows Store. There we go. Search up Ubuntu and install that. See, let me see. Yeah, so like, you can like literally just search up Ubuntu here.
Yeah, you're taking Microsoft just gave up on. I think they just gave up on like the whole CMD thing. They're just gonna build on top of Linux now.
It's just better, yeah. Well, Microsoft command line stuff is honestly the worst. But yeah, you can literally just install it, and then I'll even install it in the background, just because I want to show some setup instructions later on. Because like I'll show you how to install like G++ and everything if it does end up installing. But for now, once we run these instructions, we'll just focus on the REPL and doing everything in there. So I guess going through the steps, if you're doing this on your own machine, you'd copy this PowerShell link. You'd go here, search for PowerShell. You can go run as administrator. Hopefully your right click works. There we go. Let's just do that.
Yeah, so Linux and Mac, they use the same terminal. So Windows is the only one that has their own like special terminal.
Yeah, honestly, if you're on a Macintosh or if you're on like Linux, then doing C++ is the easiest thing for you. Just install. Yeah. You want to install something called G++. I guess Michael can maybe help you find a link, but you want to install G++, and then you're done. Then G++ is the compiler, and you can just run G++, your file name, and it gives you the thing, and you're golden. Life is good. That's all you need. But if you're on Windows, you have to do it the hard way, which is you either install like a really like bloated IDE, or you do something like Windows Subsystem for Linux.
Oh, we have a Linux fan in the chat.
Do we? Oh yeah, Linux is just indescribably better. Okay, so we'd run this command here, which enables WSL. It's enabled. Then once you have that, we go to the Windows Store, we search for Ubuntu, we press install. It's gonna take a long time to install.
Dude, wait, don't install it. Your stream. It won't be able to handle it.
It's fine. I actually have like my internet connection has like 200 download and it has like 10 upload.
Okay.
Yeah. So funny enough. Although if I do start lagging out, do start like screaming in chat because I don't have like a dying stream. Yeah. So we'll leave that in the background and we're gonna move to REPL.
All right.
Okay. So we're gonna go back to our REPL. We're gonna choose a new language. Okay.
The PowerShell is really like the text really small, but it doesn't really matter.
Oh yeah, sorry. I hope I didn't. I mean, I hope everyone still got it. I guess though you should just be looking for this link. You can copy it from here. Yeah, definitely don't type that by hand. Sorry. Okay, let's go back to C++. We're waiting for it to boot up. You'll see it says this thing here called Clang. So the two most popular C++ compilers are these things called Clang and G++. I normally use G++, but Clang is also like very, very good. It's part of something called LLVM, which you should definitely check out if you're a compiler nerd. But anyways, here we're gonna write some C++ code. And here you can see they've already given us like a basic hello world template, so we can run that and we get some code out. But there's a few things I want to touch on here. First, you'll see that there's an include IOStream at the top of this file. So C++ comes with a really extensive standard library, and to use things from that standard library, what we do is we include them. So here IOStream stands for input-output stream, and includes things like cout and cin. Oh,
No,
we have no input? No sound?
no, I can still hear sound.
You hear my sound? Wait. I'm going to wait a second. I hope chat still has my sound. Let me double check my microphone. I should. Yeah, no. My mic does appear to be sending sounds. I wonder if my Ubuntu download is just killing me. You know what? We're gonna pause this for now, just in case, because I'm paranoid. Bad Ubuntu. Okay. For now, we'll just assume it's still good. Anyways, yeah, so sorry. We've got this thing here called IOStream, which stands for input-output stream. And so this is like one of the libraries in like, sorry, it's just like part of, sorry, I know the technical term if it's a library or a module, but it's part of the standard library, and you include it like this. Now, you can include everything you want to use in C++, but this ends up being a bit of a pain. So instead, in competitive programming, we have a trick where we do include bits/std c++.h. And what this does is it actually includes every library. Sorry, not every library. Sorry, it includes all of the standard library. So you don't have to worry about including like particular things. Okay. So this can be really handy. The other thing you'll notice that's already a pain is you'll see that we do this std : thing here, and you're probably wondering like what the hell that is. So C++ has something called namespaces, and so everything from the standard library is in this std namespace, which means that to access it, we have to prefix it with this std thing. So if you don't want to do that, and you normally don't want to do that for competitive programming, you can say use namespace std, and then you don't have to do that. It'll just be done automatically. Or I guess more accurately, it gets put in like the global namespace, so you don't have to do it.
Mm-hmm.
Okay, cool. Also, another thing people do, you'll see here they have a new line. People often do, instead of that, they do endl. You can honestly do either or. What this endl does is it prints a new line, but it also flushes your output. So beware, actually, this endl can be a bit slower. So if you don't know what you're doing, you're honestly better off sticking with a new line. But just know, if you ever see an endl, all it's doing is like printing a new line and flushing the output. Sorry, I actually even explain what that is. Sorry, so for flushing the output, you're probably wondering like what that means too. So the idea is when you print things, it doesn't actually print them like right away. What it does, they effectively get added to a buffer. And then when you flush that buffer, or when the buffer gets flushed and actually goes to the screen. Sorry, I just want to say like at some point it gets flushed and goes to the screen. But if you do an endl, it forces it to get flushed immediately, which can be useful in some cases. But because it flushes the buffer, it will slow the program down. So that's why you have to be careful of using this endl.
Oh, really?
Yeah, it's really good to know.
The program?
Yeah, so
that's actually really useful.
Yeah, so it's really important to know. So in interactive problems in competitive programming, which is the type of problem where you have to like take input and then give it back and then take it again, you want to make sure you use like this normal endl, or you want to actually explicitly call flush.
Yeah.
Versus in like normal programming, I sometimes do a hack where I do like define. This is really bad coding style. Don't do this, kids. But I do like define endl as new line because this makes it not less slow.
Well, I show them your define int.
Oh yeah. We'll get to that. We'll get to other war crimes that I commit in C++ at a later point. Okay. So let's start off with the even easier stuff in C++. Yeah, disclaimer. So the C++ I'm going to show you today is not like good industry C++. This is like bastardized, like competitive programming C++. Be very wary about using some of these things in a job. They're very short. They let you write the code really easily. But some of them are like awful practice. And I'll try to point those out. Okay. So with that in mind, let's go through some basics of C++. So in C++, there's two ways to do comments. So we can do this double slash like this. Or we can do this like start thing, end thing. So he'll go, I am also a comment. So in both cases, whenever you have a comment like this is how you tell the compiler that you want your code to be ignored. Like so you don't want anything in this commented section to be like interpreted by the compiler. You want it to be ignored. Oh, talking about the compiler looking at your code, I should mention a really important difference between Python and C++. So in Python, we mentioned that Python was interpreted. And what that meant was that when you run Python, you're really running this like special Python, like this actual Python interpreter program that reads your program and like interprets each line of your program and like runs it. Now C++ is actually quite different in that, C++ is different in that you compile it. So what happens then is you run a special compiler program that takes in your C++ code and prints out this big thing called a binary. And what this binary is it's just a big nasty chunk of machine code that your computer knows how to run. So it's not human readable, but because it's just like a straight chunk of machine code and it's not interpreted, it ends up being a lot faster than just doing Python. Yeah, so I had to keep that in mind.
Do you know if the Python interpreter what it's written in? Is it C?
Yeah, I believe it's written in C. I know all of Python's like built-in extensions are written in C. So fun fact, actually, if you call something like .sort in Python, like all right, this isn't Python, so this won't make sense if I type it here, I guess. But if I call like list.sort or something in Python, internally, it's actually running like a compiled like a sort function that was written in C and like compiled down to binary. Like that's what's actually going on.
Why Ori's in chat? He's like, I love C++ Warcraft.
Oh no, Ori, no. Ori, don't join me. It's not worth it, Ori. It's not worth it. Okay. Okay, so let's go through a few basic variable types in C++. So the most important ones are we have integers, which is int. So I can go like int a equals 1. We have doubles. Like double b equals something. You also technically have floats, but you pretty much never want to use a float, because whenever you can use a float, you can also use a double. The only reason you'd use a float, rather than a double, is that a float uses like half as much memory.
Is there a speed?
Oh, I guess, yeah, maybe. So also technically, because it's smaller, maybe it'll be faster to caching, or maybe the operations will be faster because it uses something different. So maybe there's an argument there. But normally, I recommend you just use doubles.
Okay.
Yeah. Like doubles can store, I think it's up to something like 10 to the 325 or something. So it can store very large files.
They're more accurate too, right? They don't have that error.
It's like double the accuracy. So I think your mantissa is even like more than twice as big. But
yeah.
Regardless. So we've got integers, doubles, but we also have strings.
But strings, is it there by default? That's a separate library to import, right?
Yeah, this is a separate one, but if we include bit /stdc++.h, it'll import everything. So then you don't have to worry about importing it explicitly.
But in plain C++, a string isn't a type, right?
That's correct, yeah.
Okay.
Yeah, normally you'd have to do like std string
to
get this, even. So that's a string. What else is really handy to know off the top of our heads? Honestly, these are the main data types you'll use.
Boolean?
Boolean? Oh my god, I can't forget a bool. Although, to be honest, wherever you use a bool, you could equivalently use an integer, almost without fail. But you can go like bool, this equals true.
You did that bool joke in class, and then you roasted me? I was so sad.
Wait, what was this?
It was like, they're like looking at int, right? It's like, int equal 0 or something. It's like, oh, that's the same as saying this. And then I was memeing you. I was like, that's the same as saying this. And you're like, no, Michael, you're actually wrong.
Big roast.
All 200 students in class.
I'm sorry. Now we continue the roasting onto the live stream. Okay, cool. So these are the main data types you want to know. And similar to Python, you can perform operations on them. So I could say like, let's do like int d. Let's see what happens. So if I add like, maybe I believe this will cast my result to, if I add like a instant double and I store it in an int, it should cast it to an int. Let's see if this actually does that. So, don't do that. Okay. Sorry. Here's the thing. Anyway, sorry. And then to print something, what we do is you do the cout. You do these like weird arrows, and then you put the thing you want to print. And if I wanted to print more things, like I wanted to print like a space and then some other stuff, then I could just keep adding more of these weird arrows and keep adding more things. Okay, I might print 5 at the end of this for some reason. Let's try that. So this is a bit slower than Python. Okay, yeah, cool. Nice. Cool. So what happened here is like we added a to b, which would have given us like 2.5, and we would have cast that to an integer, which would have truncated it down to being just 2, and then we printed out 2. So that's good to know.
Makes sense. So I know some people like to use printf instead of cout.
So I'd stay away from that. So you can use something called, instead of like, so we're using cout here, and we're going to use like cin to read an input. So instead of cout and cin, some people use like printf, say scanf and printf. That's really like the C way of doing things. The C++ way would be like cin or cout.
So cout, does cout call printf eventually? It's just an abstracted version of printf.
I'm not sure. I'm actually not sure how it's implemented internally. I assume it might call the thing that printf calls, but I honestly can't say that at all.
Yeah, that makes sense.
I will though say though there's a thing you want to do in C++. So all right, this isn't even too advanced. So there's a really weird thing in C++ where I think the reasoning for it was, I read up on this once. Input in C++ is slowed down a bit because it synchronizes the like printf and scanf methods. So like whatever it uses for printf and scanf is synchronized with whatever it uses for cin and cout. So what you're supposed to do is you're supposed to do this thing. Let's see if I can find it. Speed up input. You're supposed to put this like weird sketchy thing at the start of your C++ code, and it makes your input just like much faster. It's called fast.io. Let's see if I can find the code to copy paste.
I think this actually happened to me where I was doing a contest, and I wasn't like passing the test cases. I was timing out, right? But then I insert this line, and then I passed it afterwards.
Yeah. So normally the red flag is if you read it more than about 10 to the 6 values, that's when it starts to matter.
Yeah. But you might as well just toss this in like all the time.
Like if you have a template or something, I just have like this line, and where's the other one? And this line just like sitting at the top of my template.
Yeah,
and it's always good to put
those 2 lines in if you're doing C++.
Yeah.
You only get benefits from it, having those there.
I mean, to be fair, I think it might break if you use this, then go back to using like scanf or something. So don't use like scanf and cin out and use these lines. Just like use c and c out and use these lines.
Yeah.
Okay. What else do I have in my stuff? Okay, all right, let's try reading in. Let's try and make the same hello So we made a program when we were doing Python that like would say hello to someone. Let's try and make that same program in C++. So what we're going to do is we're going to read in a string, and then we're going to say that string's like a name, and we're going to say like hello that name. So let's say like we have string s. To read into a variable in C++, you just go cin to s. And then let's go, ready? Cout. Hello. You'll see I include a space here in my hello, so that includes a space between my strings. And I'll go s. And let's see if that works.
Why? I see you're a fan of those one-letter variable names.
Oh yes, I never use more than one letter, except in interviews.
All right.
Okay, it's running. Oh, sorry, we have to provide input. So let's say Michael, since Michael's on the call with us. Hello. Michael.
Hello.
So we made a simple program there. Okay, now, like similar to Python, we often have cases when we're programming C++, and we want to do like something if a condition is true, and something else if the condition is not true. And to do that, we have the concept of an if statement. So what I might do is, Michael's like a sketchy guy, right? So let's go if s equals Michael, we're not gonna say hello. What are we gonna say? What are we gonna say Michael to?
Just dot.
Okay. If you see Michael, we're gonna say dot, because Michael's like working with us on a project and we forgot to do our part, so we're just gonna say
Wait, did I forget? Wait, is that? Did something happen?
No, that's not real. That's not real. I'm sorry. Okay, wait. Okay. And otherwise, we'll say hello, the person's name. So let's try this out.
I'm not sure, but like with strings in C++, can you just do that equals? Isn't there like a function like dot equals 2 or something?
No, so if you're in C, you'd have to use like that awful like.
Oh, okay, just in C. I remember using that.
Yeah.
Because the comparator wasn't.
Yes, if we do Michael, it's gonna say and if we do the same thing with Wyatt, it'll say Yeah, hi Wyatt.
Oh, okay. I don't like it.
So how this works here then? So if our condition is true, we run this code. If our condition is not true, we run this code. And in here, all our if statement does is check if this thing evaluates to true. And so here we're doing equals equals, which just compares two values and returns true if they're equal.
Mm-hmm.
Okay, so that's if statements. All right, so similar to Python, we can do a bunch of math in C++. So get ready for that. This is going to be a lot of math for everyone. So first I'm going to make some integers. Okay, a equals 1, b equals 2, c equals 3, sure.
Done in one line.
Yeah. I could just do this in one line. I don't know. I did too. But so.
Wait, can you put a comma there in that second line? Does that work? A, comma, B.
Oh, wait. Does this even work? Oh, this technically will work, but it's kind of a hack, honestly. You know what? I'm just gonna do. I'm just gonna do this. It will work, but it's sketchy. Okay. So, anyways, let's do. But I'm just gonna show you that we can print some things. So, a plus b. That's a thing we can do. We can also do. We can subtract two things. We can multiply two things. We can divide two things. And now, note, we're going to touch on this when we print it out. But this is actually floating point. Sorry, not floating point. This is truncating division.
Mm-hmm.
So let's print these out, actually, just to start.
Well, are you going to cover how there's like different integer sizes?
Oh, yeah, for sure.
Okay.
I mean, at least a little bit.
Okay.
So here, I actually haven't printed any spaces or any new lines between my things. It's kind of hard to tell. But first, I printed a plus b, which is 3, because 1 plus 2 is 3. Next, we printed 1 minus 2, which is negative 1. Does that make sense? Next, we printed 1 times 2, which is still 2. And now this last one is the interesting one. We did 1 divided by 2, and we didn't get 0.5. We got just a 0. And so why is that? That's because in C++, if you divide integers, it automatically truncates. So since 2 doesn't go into 1, it doesn't even go in once, it only goes in 0.5 times, we say that it goes in 0 times because it truncates down to like the value below. And so we get a 0 here. Another handy and sort of related thing is modulo. So what modulo does is it gives us the remainder division. So if I do something like 10 divided by 3, here I'm gonna give us a new line so we can actually see where this is. If I do, oh wait, I don't want 10 divided by 3. What am I doing?
Copy paste on everything.
I really should just copy and paste that around everything, but I've already given up on this first 4 lines. Okay, wait. So this modulo operator gives us the remainder. So if I go 10 modulo 3, it's saying what would the remainder be if I divided 10 by 3? And in this case, that would be run 1. Oh, what is this? What is this? What is this ID? What is this revel?
You ran it before you did the save.
Okay, well, let's do it again. Okay, there, sorry. So we see we get 1. Because if I did 10 divided by 3, I would get 3.333 something, and I would have a remainder of 1. Similarly, if I did like 11 mod 3, I'd get a remainder of 2. And if I did 12 mod 3, I'd get a remainder of 0, since 12 evenly divides 3. Okay, so next let's take a look at for loops. So I'd argue for loops are actually easier in C++ than in Python. Because how they work in C++, they have 3 parts. And the first part is we define a variable. Next, we have some condition for the variable. So I might say like I is less than 5. And then we have how we want to change the variable at the end of each loop. So here I want to increment I by 1. So this will be something that loops from 0 to 5. So let's try that. And let's just print out our I so we know what we're doing. So here I expect this to print out 0, 1, 2, 3, 4 on each line. Yeah, see, we printed 0 to 4. Now what's kind of fun about for loops is that all these sections are technically all optional. So if I wanted, I could bring this out here, this out here, and I could put this here.
Oh, okay.
and this would be like equivalent. Oh, let me actually add a semicolon here though.
Mm-hmm.
Cool. And now if you're going to do something like this, what we've really done here is we've really just created a while loop. So instead of doing for here, we can do while. And if you do while 1 or while true, your loop will just run forever until you call break inside of it like we've done here. So break just takes us out of our loop. And why is this bad? There we go. Okay. So if we just do while true here, we'll see we get the same behavior. Once it runs, yeah. More commonly, instead of doing while true, we can put a conditional on our while and do something like, well, I is less than 5. Do something like this. So you can see there's a lot of different ways to accomplish the same thing.
Mm-hmm.
Okay, now we're going to try and do something that we did previously with Python, and that is we're going to read in 5 integers and try and sum them up with our C++ program. So to do that, first we need something to store our final result in. So let's make an integer variable called result, and let's set it equal to 0. Actually, while I'm talking about these integers too, not to interrupt myself, but Michael, should I should mention, so there's different integer types in Python. So there's int, but there's also short, there's also long, there's also even a long. And these different integer types can store integers of different sizes. So I believe int is like a 32-bit integer, so you can store up to around 10 to the 9. Whereas if you do a long, that can store up to around 10 to the 18.
So what's the difference between a long and a long? How much?
So longs are sketchy. Longs actually, on a lot of in most cases, I'm pretty sure a long will actually be the same as an int. So it's like pretty useless.
Okay,
Yeah.
so long is 64-bit.
Yeah.
So it's 2 to the 63 values?
Oh, it's not exactly. I think it's like 2 to the 63 minus 1 or something. Oh, wait, don't quote me on that. You can look it up. You can look it up the actual value.
Oh, minus 1, yeah.
And
there's also unsigned int as well, right?
Yeah, sorry, I should mention as well, yeah. So these are all signed integers, which means they can go negative or positive. Mm-hmm. If you only are working with positive values, you can use something called unsigned integers. You do unsigned int. But I normally recommend staying away from this, because this has C++ has really weird behavior with unsigned integers, where if you try and do an operation with an unsigned integer and a signed integer, it normally converts them both to unsigned, which can lead to like pretty catastrophic errors that are really hard to track down. So if you can, I just would keep everything unsigned. It's normally much easier. Okay. Okay, so with that in mind, Michael was alluding to this. So normally the standard way of working with long-longs in competitive programming is you do define LL as long-long, and then in your code, instead of typing out long-long, because that would take forever, you just type out LL, and I can just do stuff like this. So that's pretty handy. Now, if you're a person like me, what you do instead is you do define int as long-long, so you can still type int, and it actually isn't really an int, it gets replaced. But that actually technically breaks your code right away, because then it replaces this with long, which is really bad.
Oh my gosh!
So you have to do things like you can either use a separate function, or even like put this down here, which is okay.
Jesus Christ!
Yeah, so these are, I don't recommend that, but if you want to use some of my sketchy hacks, this is like C++ war crime number 1 is this. Okay, so with that in mind, we have some variable that's going to store our sum, and now I need to read in 5 integers and add them to our sum. So that means I need a loop that's going to run 5 times. So I can just go for int I equals 0, I is less than 5, I plus plus. Now I have a loop that runs 5 times. Now I need to read in a value. So to read in the next value in C++, we can just use cin. So here I define a variable to read it into, and I can go cin here to x, and this will read a value into x. Now, if you guys were watching this from the Python section, you'll remember when we read an input in Python, it read in as a string, and we had to cast it. But in C++, we already tell C++ we want this as an integer, so it knows to give it to us as an integer. So we already have an int now. So we can actually just add this directly to result.
Okay. So that x is just a temp variable, right?
Yeah. And then we can see out like our final value of result.
And that x, is it scoped only within that for loop?
Yes, very good point, Michael. So this x, since we defined it in the scope of like this for loop here, it's only accessible in here. So if I went out here and I tried to access x, I'd actually get an error and it wouldn't compile. My code wouldn't compile.
Yeah, but in Python it would work. So in Python you'd be able to call it outside.
Yeah, Python does some hacky things.
Yeah, they do scope different.
Okay, so let's try this. So we run our code, and I should be able to type. Oh, it's still loading. There we go. Let's go 1, 2, 3, 4, 5, and it sums them up. Now, what's interesting about C++ and Cin is that Cin just grabs you the next value and kind of like discards as much white space as it needs to. So if I did something like, if I gave 1, then I did a bunch of spaces and I gave 2, and then I did some new lines and I gave 3, I added more space, did 4, and added another space, did 5, this would still read in just like normal. So that can make taking input in C++ a lot easier most of the time. Okay. Nice, so that's that. Okay. Oh, yes, go. So another thing we should cover in C++ is something called a vector. So a vector is sort of similar to Python's list, but it's a bit more strict. And when I say it's more strict, that's because a vector can only hold things of one type. So when I declare a vector type, like I'm declaring something here, I'm going to call it myvec for my vector, sure. And you see here, I do this weird thing where I do like a left arrow, the name of a type, and a right arrow. This is telling C++ that my vector is only going to hold things of type int. And then if I want to actually put things into my vector, I can do like myvec dot pushback. Let's see. Yes, right. I do like pushback 1. So this would push the numbers like 1, 2, and 3 onto my vectors. Then I'd have like a sequence of 1, 2, and 3. And then, similar to Python, I can index into the structure. So if I go myvec at 1, let's say. Actually, I'll clarify it. So this is a 0 index structure. So consider we have our myvec, right? So at this point in the code, myvec is going to look like a sequence with 3 elements in it. So 1, 2, and 3. And so vectors support the concept of indexing, which means I can say I want to get my vector and get the 0th element. And that would give me the element at offset 0 from the start. So like if I see out my vector, I expect it to give me a 1. But if I made my offset bigger, like let's say I did like see out my vector at 2, this would say I want the value with offset 2 from the start of my vector. So if I go to the start and go offset 2, so 1, 2, that brings me here, and this will give me value 3. So if I print this now, I expect to see the values 1 and the value at offset 2, which is 3. So let's see if that happens.
So in Python, Wyatt, if I want to print out my vector, right, I can just do print myvec, and it'll print out the vector, right? Is there a nice way to do that in C++?
Not really. So Mikhail, I don't think Mikhail's in the chat today, but if Mikhail might disagree in that you can write your own function. You can write your own sort of like almost like a standard library-esque function that'll just automatically be called. That'll work, but then you have to do that, which is a bit of a pain. What I normally do if it's during a contest is I go. It's a one-liner even for int e in myvec. We should go. And I normally, so here's another tip too. If you're in C++ and you want to do something that's only one line, like I want to like do a loop like this, but I only have one line of stuff, then I can actually omit the curly braces and it will still work. So here I'm going to omit my curly braces and I'm just going to go for every element in my vec, cout element, and put a space at the end. And then put a new line at the end of all that. So this will go like element space, element space, element space, and then it will print a new line. So let's try that out. I expect it to print 1, 2, 3, and then new line. Cool. So that's pretty handy. I do that a lot during contests.
So right here, you're doing int e, right? You can also do auto e, right? If you want.
That's actually very correct. So C++, since C++ 11, there's been a keyword called auto, and it will automatically try and determine the type. So I believe I should just be able to do this auto here. I don't know why it's giving me a weird warning there, but I should be able to do this auto, and I believe it should still work. Let's see. There we go. See? And so that still works.
So now you can pass in like a vector that's a string a float, a double, and it'll still work with the same logic.
Yeah. You can also, instead of just like pushing back items into your array, you can instead like pre-allocate a size. Like if I had a vector of 3 elements, I could pre-allocate it with 3, and this would give me a new vector where all the elements are just assigned to 0. So give me a vector of size 3 over all 0. And then I can also provide a second argument, like if I provide a 7 here, that sets the default values. This would give me a new vector of size 3 where all the elements are 7.
Yeah, and this is more efficient, right, than do that pushback because the resize.
So resizing vectors is not that expensive, but it's much more expensive than like just sizing it all right at the start.
So if you know your bounds, you just set some size and then set the values directly.
Yeah. Now you may feel like at some point like this is like a lot to remember, and I can't remember all of this. Well, don't fret. If you're ever unsure about something in C++, just look up the name of that thing. Like let's say I'm unsure about vectors, and now look up the word CPP reference as one word, and it will take you to this really awesome reference site. And this will tell you all about that data structure. And if you can like scroll down here and see all the methods it has, and if you click on a method, like if I click on like pushback, for example, I can see an example of like how to call pushback.
Oh, so they updated the site. It looks better now. Did they update the site? It looks different.
Oh no, you're used to seeing. So there's really 2 C++ reference sites. There's also C++. If I just search up C++ reference like this, it'll probably take me to this site. So this site's not very good. I don't recommend this site. So you might be used to the site. Don't go on this site, even if Michael tells you to. Instead, go on this site. This site is like
a programmer, so I don't know.
Infinitely better. Yeah. Highly recommend. Okay.
No one's zooming on your browser, but it looks like it's the font's a bit small.
Oh, really?
I should browser, yeah.
I should zoom in. Although, is my REPL okay?
REPL looks good, yeah.
Okay. 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 So that was honestly most of my content for C++. The one final thing I want us to look at is how to read in an array in C++, because that's just like a really common operation. So the most common like input code I do in C++ looks like this. So normally they'll give you a problem that says, well, let's see if I can still type this out from last time. It's given an array, given an integer n followed by n space separated integers on the next line, and then like do something. So you often have problems like this where they give you an array, so they tell you its size, they give you the elements, and they want you to do something with it. And so whenever you have a problem like that, you can take input by doing this. You go, I want integer n, I'm going to read an n, then I'm going to make a vector, I normally call it a, and I'm going to pre-allocate it to have n elements. And then what I can do is I can make a for loop that iterates n times, and each iteration reads into a at I. So this will get me a vector of n elements from my input. So this is like, these are super useful lines. It's a bit more verbose than Python, but it's really handy. Yes, that's the thing to know. And I guess with that in mind, we actually steamrolled through our C++ content. I think we're ready to try a question. Now, before we move on to a question, I want to point out, so we did really steamroll through the C++ content. And I will say you don't need to know much more of it than this to do like OK in competitive programming. But if you do want to know a bit more, I highly recommend even just working through the basic syntax section on the tutorial point for C++. Like it honestly does a pretty good job of going through everything. And it only takes like maybe, I'd say like an hour or 2 to go through. So it's not bad.
Yeah, we plan doing like another workshop for C++ with more like library, like sets, hash sets, all that stuff.
Definitely. We're also doing I don't know if other people know, but we're also doing our data structures workshop at some point soon.
Okay. And is that going to be
we could make our workshop specific to either C++ or Python because it's quite different depending on the language.
Yeah.
I will say though, generally in competitive programming, there's a large initial barrier when you're first learning in terms of like just like learning how to do things in C++ or Python, or even Java if you're into that. But
we'll talk about Java here.
Java zone. But sorry. But like once you get past that initial hump, most of the difficulty ends up coming from like the algorithmic problem solving rather than like knowing your language. So then like your language differences and things tend to matter a lot less, which is good.
All right, okay. Let's see the hacker rank.
Let's do some easy hacker rank problems. Okay.
So a hard one. Do one easy one. Do a really hard one.
Do a really hard one. Okay, we're gonna do our easiest one, and we're gonna jump to
Yeah.
Ooh, we're gonna jump to like code forces
That's too
problem.
hard. I think it'll be good to see that, like, even though the question is a harder question, it still uses the same code, you know?
Yeah.
All right, what's your easy one?
You know what? Simple array sum, Michael. It's your favorite.
Oh, we're just doing
Boy.
the same one?
Oh
Same one?
yeah.
Okay, you have to do staircase. I get PTSD when I see staircase.
Okay, we'll skip it. We'll do some harder one instead of staircase. No more PTSD. Okay, so here we go. C++. First step on any HackerRank problem. In C++ in particular, HackerRank has the most disgusting template code. Highly
Oh
recommend you delete all of this.
They have the good lines, the two good lines at the top there.
Yeah. So now we can just go include bits less. Yeah, they do have this line. These lines which are good. I normally, what most people do is they just make a C++ template and they copy and paste it whenever they do C++. Then you don't need to worry about typing all this stuff every time.
So right now you're typing the lines that you type every single time, right?
Yeah.
So
Although I guess I normally never type these just because I copy and paste them. But
yeah. But in general, you just type when you start off, just type these lines,
yeah,
regardless of the question. This is like the bare minimum you need.
Yeah. All right. And now we can use our input code that we came up with earlier, and that's really easy. It's just like int n, read in n. All right. Let's see. Okay, sorry. Let's declare a vector to hold our array elements, pre-allocated to a size of n. Iterate through. I normally do this as a one-liner just so it takes up less space. I'll go like, you can even put it like literally on the exact same line. Go read into array I. And now let's sum them up. So let's go int result equals 0, 4. So similar to in Python, how you could do like for something and something. In C++, you can do that too, where I go like for int e in A, I can go like result plus equals e, and then go coe. And here you'll notice that we really didn't need to store this in a vector either. We could have read it in and immediately stored it in this, but I thought it'd be fun to try out our vector input code. So let's run this, see if it works. Compilation error. Oh no, luckily we get a nice warning. So right away, first we see E was not declared in the scope. Why is that? Because it doesn't like the 4.
Looks like you're doing.
Yeah, it doesn't like the 4 because I'm missing a semicolon right here.
Oh, you have a semicolon. Okay,
yeah,
never mind.
As a general warning, if in C++ you get an error saying it doesn't like this, like the start of a statement, the problem's normally on the previous statement, and it's because you forgot a semicolon.
Do you know if on HackerRank, when it says C++, do you know what version that is by default?
I think it's C++ 11. The reason I think that is just because you can explicitly choose C++ 14.
Yeah, so you might want to jump over to that one because right now it says the E is not defined, right?
Oh no, it'll definitely support that. That's definitely a thing, I think.
Oh, because you need the curly brackets.
Yeah, no, that's because I did this. I did this.
Result. Not.
You don't. I missed I had an E here for some reason. That's why.
Yeah. Okay. Yeah, you want to print the result, right?
Oh yeah. What am I doing? Good point. Good point.
Okay, dude. It's been a long live stream.
Sorry. There we go. Believe.
So that feature, when was that added?
That for each loop? That's old, dude. That might even be like older than C++ 11.
Oh, really?
I don't know. Yeah, at least it was in C++ 11 for sure.
So the auto thing is the only new thing.
Even auto C++ 11, dude. Like I think, most features after C++ 11 were a bit more esoteric. If you want like unique pointer or like something else that's funky, you need that.
Okay.
But like for competitive programming, C++ 11 will get you through most stuff. But I think on code forces, which I always show, I think you can actually choose what you want. So you can do like C++ 11, C++ 14, or even like C++ 17. So that's pretty nice.
Is there a reason you would pick the older version over 17?
Not really. So yeah, then you ask like, why am I not using the most new version? I don't have a good reason. It should be effectively the same.
Okay.
Yeah. Okay, so that's easy problem. So for our next problem, Michael here said our problems were all too easy. They're too easy for Michael.
Yeah.
So we're gonna do a code forces problem. That's also quite easy.
Okay. We're going all the way.
Yeah, we might even do 2 code forces problems just for Michael.
All right, come on, it's 9 o'clock.
The first one's pretty easy. So I mentioned this in the Python section, but HackerRank's like a steaming pile of junk. You shouldn't use HackerRank. If you want a job, you should use LeetCode. If you want to do competitive programming, you should do code forces. That's my very opinionated opinion. But I think you'll find.
room.
Yeah, I think yeah, I think find code forces is a good resource for this.
Okay.
Okay, so here's our question. I'll also link it in the chat if people want to read this.
Yeah, zoom in.
Zoom in all the way and link it. Okay, I'll let Michael read it too, since he's reading it for the first time.
I actually can't read. You should probably just read why.
Okay. So for this problem, one hot summer day, Pete and his friend Billy decided to buy a watermelon. They chose the biggest and the ripest one in their opinion. After the watermelon was weighed, and the scale showed W kilos. Now they rushed home, dying of thirst, and decided to divide the berry. However, they faced a difficult problem. You see, both Pete and Billy really like even numbers. That's why they want to divide the watermelon in such a way that each of the two parts weighs an even number of kilos. At the same time, they actually don't really care that they both get the same amount. Like, it's okay if the parts are unequal. Now, the boys are really tired and they want to start their meal, and so it's your job to figure out if they can divide the watermelon in a way that satisfies their conditions, such that they both get like a positive weight.
Okay.
And so they just give us the watermelon's weight as input, and we print yes if we can divide it, and no if we can't. So I'll have Michael try and walk us through the insights here.
All right. So I guess the first thing I would do is you're just gonna do on REPL.
Yeah.
First thing I'm gonna do is I am going to look at the input. Oh, why'd you erase the bits std?
Oh, actually, very good point.
The very first thing I'm gonna do is
type your template.
std_c++.h.
A.
Add that using namespace, and then I'm just gonna get the input. So I'm gonna store that input as weight. So I'm gonna do int weight.
Okay.
And then I'm just gonna read that value in. So now I have that weight stored, and I'm just gonna process it. So what they want is they want to figure out if we can divide it evenly amongst only two people, right? There's not multiple.
Divided, so not so it's like the same amount given to both per person, but so that each person's amount is even.
Each person's amount
is even. So, like, for example, like we see an example here, if it was weight 8, it would be okay if we gave them both 4 kilos, or if we gave one person 2 kilos and one person 6 kilos.
Why is it okay for 2 and 6?
Oh, because they don't have to receive the same amount. They just need that both their amounts have to be even, because 2 is an even number and 6 is an even number.
Oh, okay.
Like the actual split, like how much one person gets versus the others, it doesn't matter.
Okay. Okay, that makes sense. So I guess the idea would still be the same, right? Like you just have to check if it's an even number, because if it's an odd number and you divide it, 2 even numbers can't equal an odd number.
Right? That's a really good insight. Yeah, if it's odd, there's no way we can do it, because like you can't add 2 even numbers to get an odd number. Now, I will say, Michael, does this work for weight equals 2?
No, it does not. So, but that is an edge case, right?
That is pretty much an edge case, yeah.
Yeah, so that's the only case you have to watch out for. So you can do a special case. So if weight equals 2, then just print no, or like whatever they want us to print. Just C out no. But then if weight is an even number, print yes, else no. I feel like you can do this all in one line.
Yeah, let's do this on one line.
So if weight is not equal to,
it's not equal to 2,
and weight mod 2 is 0.
So this print yes. Is even. Okay.
Yeah.
Then we do yes.
Else no. With a new line. Yeah.
And here we go. Okay. And once we have our code, all we have to do is copy and paste this. Go on to Codeforces. You want to make sure you've signed up with a Codeforces account. So here I'll sign in. So I'll go, signed in.
So yeah, so I guess with contests, like question A is always like this level, right? For
it's normally like this. It's pretty easy, and it gets much harder. So actually, I'll submit my question, and then I'm going to talk a bit more about that actually. So here we can go submit code.
Okay.
We can say I want to do this watermelon problem. We see here we can choose like what version of C++. We can do like C++ 11, 14, or 17. we'll just do 14.
There's C-Lang too, right? There's like other
Yeah, there's also
compilers.
Clang. Clang is good. I don't know if they have Clang here. Yeah, they
They
don't
do
have.
have a,
Oh no, they do. Oh my gosh, yeah. Okay, sure. But we'll just do GP++. Okay, so let's do that, and we can submit.
So normally a question like this, how fast would someone do it
Oh,
in actual contests?
like less than 5 minutes for sure.
Hmm.
Because this is something you can see right away and figure out.
It's like a 1 minute, 2 minute question, right?
Yeah, easily. And so the idea is then the questions get like harder as you go along. So let's look at an actual contest as an example. So if you sign up for the site called Codeforces, which I highly recommend if you're really into competitive programming or want to get more into it, you can go to this contest tab and see upcoming contests. You can also see these like past contests. So here was a past Div 3 contest. And there'll be a bunch of questions, sort of similar to the one that we just saw, where each question has forget my computer, it takes a while to load. Sorry, each question has some description, and then it has an input they give you and an output you're supposed to produce. And you have to submit code that solves the problem. And the idea is if you solve more points, so if you solve more questions, you'll do better on the contest and you'll get a higher rating. And so
what does div 3 mean?
Very good question. I was just going to say that. So you'll see this contest has div 3. And if you look back, I guess I can't see it here, but if you look back at the contest panel, you'll see some other things said like div 1 or div 2. That refers to the difficulty of the contest. So div 3 contests are like the easiest contests, and div 1 contests are like super crazy, impossibly hard. But even div 3 contests aren't like trivial. Like they're still like decent contests. So if you're just starting out, I highly recommend you mostly write like div 3s, and you can try div 2s, but like don't be turned off if you only solve like 1 questions or sometimes even no questions on div 2s to start.
So from what I've noticed with div 3s, it's mostly implementation question.
Yeah.
So if you like understand the concept of what they're trying to ask you and what you have to do, you just implement something. You don't have to worry about like any complex data structures.
Yeah, so especially if you're starting out, like div 3 is like amazing. Like maybe like the first half of the problems, as Michael said, are like just straight implementation you can do, and the later ones will require a bit more thought, but they're still very doable. And from writing those, you can like get more familiar with it and get better. And I think it's pretty fun. You can also like add friends on this and like watch your friends and things, which is fun. So back in the day, we used to do most of this on HackerRank instead of Codeforces, but then HackerRank basically stopped hosting contests, so Codeforces is really the place to go now. And it really can, like, I guess, be good for people with like a variety of skill levels, since they have this big variety of contests. Yes, definitely check that out. And I think, let's see, we covered all our Python content, we covered all our C++ content. Now that it's done, I think I just wanted to do maybe like even just like a 10-minute like Q&A or something, since I know you guys have been sitting here for a super long time, and you might have like specific like Python or C++ questions. So you can ask us anything. And I guess while we wait for our C++ questions, Michael, do you have anything to say?
Put
you on the spot. No?
How's your internship, or not internship? You're graduating. How's the job looking thing
job
going?
Prospects? Oh, we'll see. So I'm still waiting back. It's like literally like supposedly in days I'm supposed to hear back and see if I got the job that I was working at this past summer, which would be really fun. Because that would be like some like hedge fund in New York, which I want to point out. The only reason I ever got the like interviews or anything for that job is because funny enough, that company sponsored a few competitive programming contests. And so like so I basically heard about them from my friends, and then I applied, and I ended up getting a position because they saw I did like competitive programming stuff. So I can really help you stand out.
Yeah.
I guess in particular like ICPC, which is a contest we do every year, which will be next semester this year, is a really, really great way to stand out. Like I swear some companies just like Control F for ICPC in your resume. Like it doesn't matter even if you didn't like go to Worlds or anything.
So I have some insider information. So Google is releasing their job posting for new grads in January.
Really?
Yeah. So I don't know why they're doing it so late. That's so weird.
That is kind of bizarre. Yeah, things are weird this year with COVID for sure.
Yeah.
I mean, that's the same reason that ICPC was delayed. See, another job I was trying to get, but I don't know if I'll actually get it. I was applying to be an algorithm engineer at some company, which would be really fun. It's like an algorithm in my job title.
So, like a job like that's mostly in finance, right? Are you just interested in staying in the finance area?
I'm still not sure. So it's funny. I feel like I don't have a huge inherent interest in finance, but I like the actual work. Like I like the programming work they do to support the finance stuff. Like I don't think I'd ever want to be a quant, but being like a software dev that supports quants seems kind of cool. Because I find like when if you're working at like Microsoft or even like, I mean I haven't ever worked at Google, so I can't say. Michael would know better. He's a former like Googler. But I find normally when you work at like a really big company, you end up working on something pretty niche. Like you become the niche guy that does X. So you become so good at doing X, and you know everything about doing X, and you're really good at your niche. But it's like it's not that interesting. It's not that much work, and I don't know. It's not like there's not a whole lot of challenge in terms of like algorithms or problem solving. It's mostly just challenges in terms of like code organization and understanding how things are like already done, which isn't very exciting.
Yeah, definitely. So if you want to become like an all-arounder, like just good at coding in general, I think like working at a startup is probably the best.
That's good. But I think what is it? People say like don't expect to actually strike it rich as a startup. Like I don't think it's normally in your best interest. Like if you're there to like if you're like working for free, hoping the company is going to be like some unicorn, like I feel like on average that really doesn't work out for people.
But there's different levels of startups too, right? There's like the like early startup that like don't pay you. Then there's the ones that like the unicorn ones that like pay you like a lot to work there. But even at those, like you get to work in a lot of areas.
Yeah, it can still be better.
And also make money too.
Let's just be wary. Let's just be wary of like different roles and how much stuff you actually do, because it's super easy to get kind of like I don't know if pigeonhole's the right word, but to get kind of like pushed into like some like very particular niche role and just like sit there.
Yeah, that's definitely an issue with like working at a big company.
Yeah.
Kind of just max min what you're learning.
Yeah. Oh.
I maximize this and never learn anything else.
Also, it's funny. Like algorithm questions are the standards for like hiring. Like pretty much no matter where you go or where you're trying to work, you're going to see algorithm questions in the interviews. But it's less likely to use it as much on the actual job beyond like a simple like depth first search or like other things. Like you rarely will use like advanced like dynamic programming or like some crazy geometry concept on like in your day-to-day work. Although I would argue that the sort of problem solving you pick up from doing competitive programming still remains like extremely useful.
Yeah.
Cool. If we don't get any questions, I think I will close the stream at 7:15, which will be in 3 minutes. So if you have questions, make sure to get them in now. Although I guess you guys might be used to hearing us like almost every Saturday, so probably already got in a lot of questions.
Yeah. Well, are we done with the Saturday contest?
There's just one more. The last one's pretty hard actually because it's like geometry and flow, which are both hard concepts. I think I'll do like one geo question, one flow question, and the rest will just be like easy questions.
Yeah. It's super funny because we started this in the summer, right? And then the school year started and a bunch of first years got interested. So they're entering it, and when they enter, it's like we're on dynamic programming.
Yeah, we're on like it's funny, we're on like really hard concepts now, so I feel bad. That's another reason why I want to do these like really easy workshops now.
We'll refresh it. We'll do the.
We'll go through slowly and actually go through the content for everyone. Yeah. So don't be stressed out. Like, don't feel like you have to attend a contest like next Saturday and do some crazy stuff.
Yeah.
Oh, thank you. Actually, Michael, when did you start Python? Just first year?
Python. Yeah. So in high school, I didn't really code anything besides like Game Maker. So I used to make games.
Nice. Dude, I never did Game Maker. I used to do action, like Flash games, like action script, like day and night. Loved it.
I did game making in high school, and then in university, all of first year, I barely programmed, and then the summer of like the end of first year, that's when I started like really programming.
Right? Actually, I feel like I was sort of similar in that for me, like the summer of first year, I was doing a co-op that was like it was only my first co-op, so it wasn't like that intense or anything. So I had a lot of free time. So when I was at home, I was doing like pretty much like nonstop, just like HackerRank, which is really fun. Because that was back when HackerRank had like almost like weekly contests, and you could ride them with friends. But now HackerRank's like dead, and they don't post contests. So I guess.
Dude, I remember that summer we were always doing HackerRank.
Yeah. Well, it used to be fun because it was so easy, but now it like just doesn't run. So you have to do code forces.
That was a HackerRank summer. Yeah, I remember back in the day, what was it second year?
Mm-hmm.
Like we would literally be in the middle of class doing a contest, right?
Yeah, it was like, do you remember that question with the server racks that you get pushed over?
Yeah, that's a good one.
I remember like sitting in the back of class, like trying to solve that. It was in the middle of like a concurrency lecture or something.
You know how annoying we were? Like,
it was earlier. It was earlier. It was in the second year, right? What would have that been? I don't even know what that would have been.
there was the chess one. That was definitely one we did together.
Oh yeah.
What was it? We were so annoying in class because we didn't want to talk in class, right? So we would just make huffing sounds. So I would just look at you and go, and then you'd be like, but we're
Oh.
looking right at the front, and the professor's just staring at us the entire time. And then I would tap Lucas on the shoulder, make him look at my laptop. I'd be like, And he'd be like,
Time limit exceeded.
And we were just shaking our heads, and the professor's just staring at us the entire time. So they're trying to Wyatt, so they know like we're probably not messing around. We probably never got mad. So that's good.
Those good times.
Good times, man. Good times.
You know, it's actually, I find it way easier to write code forces contests now because since all my lectures are recorded, if I have a recorded lecture at the same time as a contest, I can just do the contest and do the lecture later, which works out.
Yeah. Do you have any advice, programming advice, career advice before we sign off?
Ooh. Oh, career advice? Never feel like it's too early to do a co-op. I feel like I met so many people who are there in their second or even like their third year, and they're like, you know what, maybe I'll do a co-op like this year, but maybe like next year. But really, it's never too early. You can get a co-op in first year. Getting a co-op in first year is hard, but like it's still possible. And if you don't do first year, you can definitely try for second year. Like, don't be too intimidated. Like, don't feel like you have to know like absolutely everything about programming to get a co-op. They expect you to learn a lot on the job. They expect you to not know everything.
Also, and the vice versa is true too. So if you don't get a co-op, don't panic either.
Yeah.
Right? Because I think in second year, a lot of people got co-ops, but I didn't get a co-op. But what I ended up doing was I just kept applying for jobs, and I got my co-op just a bit later. So while people were working in the summer, I was just applying for jobs, and I ended up getting co-ops just a bit later in the year. So,
yeah, so did I. And I think it worked out, considering you went to Google after, I think it worked out pretty well for you, wouldn't you say?
what? I only did 2 interviews, and both of them landed. And so I never had to interview again.
That's the way to do it.
Yeah. Lucky me.
So what others good career advice to end on?
I guess for like first years, if they're trying to like figure out what engineering stream to go into, like don't worry. Like if you want to get into like software engineering, right, and you don't get into it, I wouldn't worry either. Because I have a lot of friends in like different streams, like computer engineering, electrical engineering, and they still end up at like Google or Facebook or Amazon. Like
Yeah.
it doesn't matter what stream you're in.
Yeah, so pretty much the criteria to get a job at big tech co is you need an undergraduate degree and you need to know how to program most of the time.
So yeah, so you can still apply for like big tech jobs too if you're in a different stream than software. And like the software courses don't really they teach you some things, but it's not necessary.
It's not that much. Like
yeah.
And so we just got a really good question from Blake in the chat. He says on WSL, like what ID do you use? So I just use straight Vim. I love my Vim. I use Vim and I compile with G++. But typing out G++ and all the flags would really suck because that'd be a lot to type. So what I do is I just I use like an alias. I use an alias. I alias like the letter F to do my compilation, and I alias the letter R to run my program, and then it becomes like pretty clean.
Yeah. If I was on WSL, I would use Vim as well. Yeah. But if like you aren't comfortable with Vim, just use VS Code, Visual Studio Code. That's a good alternative too.
I have another friend. There's a guy I know, Daniel Wolf. He's actually the former MCP president. He does all his C++ in the Windows subsystem for Linux, but on VS Code. You can do that. That's good. Oh, advice on resume for Ori supporter. Well, actually, Michael, you go first. I'm gonna think.
Projects. I think projects really important.
Especially if you don't have like work experience yet.
If you don't have work experience, definitely put projects at the top. So the way you want to structure it is you want to put everything coding related at the top, right? And then like education, like where you study is irrelevant. So just stick it at the bottom. That's how I feel about it.
That's what I do as well. I actually
put my education at the bottom. Like it's like so irrelevant, right? But then I put all the projects I've worked on at the top. So what I used to do, I used to put coding languages that I know, but I took that off my resume because in industry, you should just be expected to be able to write in any language.
Yeah, it's like anyone can write like one line of C++ and say like, oh, I'm a C++ pro. I got it on my resume. Like it doesn't really say anything. Versus if you have something that's more measured, like I actually worked at a job doing like C++ or something, or I actually did well in a contest doing C++ or something, or I built this thing using C++. That looks a lot better.
Yeah, and also there's this really popular resume type I like. So everyone uses this. Basically, it got really popular, and everyone in tech uses this now. It's called Awesome CV. I'll just toss that in chat.
Ooh.
If you want to just make your resume look nice without like too hard, I would just use Awesome CV. But the only downside is your resume won't be that unique, but it will be structured.
Yeah.
Yeah.
I just saw another quick question from Blake. He says, how do you use VS Code? Is there a GUI for Windows System for Linux? Good question. So from Windows, you can still access the files that are in Windows Subsystem for Linux. Mm-hmm. So it's like you go into VS Code, you open up like the directory where your Ubuntu, your files are stored on Ubuntu. So you like navigate. I think it's like I think I actually have most of the path memorized. It's like C user, your username. I think it's like then like app data, and then under app data there's like the sketchy thing you go under, and then you can like find like the root of your Linux and like find where your files are. But sorry, you can look up that path online. Like you don't have to guess it. So you find the path where your Ubuntu files are stored. You open that up in VS Code, and then you can pretty much just use VS Code normally.
What is it? So another thing you can do is you can actually run the WSL inside VS Code too.
Oh, really?
So yeah, so you open up VS Code and you can open up a terminal in there, and you can choose between using PowerShell or Bash. So when you choose Bash, that will default to WSL, I believe, and then you can just type, what is it? You just type like Linux commands inside VS Code.
Like Python this or G++ this. Or...
And also, if you, let's say you make a file, right? If you make a file on your desktop, if you hold Shift and then you right click and you have WSL installed, there's like an option, be like,
open this within WSL. Yeah.
Open this folder in Linux or something. It's one of those.
Yeah.
And it'll actually open that folder in WSL for you, so you actually don't have to navigate to it.
The one thing I will say to be a little bit cautious of is that your line endings can get messed up for something. So be careful about opening like Windows files, because I think it's like Windows uses like a weird like carriage return thing at the end, and Linux doesn't. So you can get kind of screwed on that. So just be aware of that. But you should be fine.
They use like I saw a video about this actually recently. It was like Mac and Linux can use like the hex like 000A, and then Windows for some reason uses 0B0A hex code to represent new line, which is weird.
So good things to watch out for.
Yeah.
I think that's.
Yeah, for VS Code, I'm pretty sure there's like tutorials out there like how to use VS Code with WSL. But the way I did it, I just make a folder on my desktop, or just make it in like Windows, just Shift right click, and then there will be the option there to open this folder in your terminal, and you just work from there. It's a lot easier to do it that way.
What else is nice? Well, I guess another silly thing, this advice might be avoided by COVID, but if you're applying to jobs, try to apply to jobs pretty early, like late August, or I guess throughout September, but ideally even early September if you can. Now that advice is probably like mostly like not accurate this year with COVID, but in general, that's like a good thing to follow.
Yeah.
Oh, also if you don't have work experience and if you're looking to build projects, hackathons are an okay way to like go somewhere for a while and build a project. Although I'm honestly not a huge hackathon guy, but what do you think, Michael?
So I went to honestly, I feel like we hate hackathons just because that one time we did.
Oh, because of Delta hacks? Yeah, we got really cheesed. We worked really hard on this one Delta hacks project and we got like super cheesed. It was like we made it. What was it? It was a speed reading app.
It was a VR
speed reading app. Yeah.
Yeah. So we made this whole application that's like VR reading. So you can pass in like a book, right? And then like words will pop in front of you. So you can read it in virtual space. So you can like read it on the beach, read it everywhere, right? So we made that, and we're like, okay, this is an okay project, right? But the reason we got mad was because there was another project that beat us, which was exactly our project minus the VR. Yeah. So all they did was they passed in a book, and the text would just pop up on the screen like really fast. So we had that plus a virtual reality environment. And then after that point, we just we're
just so cheesed. That was no right out of there. Oh, good. Technical interview advice: how to study. So I always feel really bad. I always recommend people do LeetCode, But I myself have only done like maybe like a dozen leak code questions at most. Just because I'm more familiar with code forces and stuff. If you do like pretty much no matter what, so long as you do competitive programming stuff, you'll be in a good spot. But if you are like you have an interview coming up and you just want to study like solely for the interview, I'd recommend just like grinding leak code and like
Yeah.
and look up like common questions for the company you're going to specifically. Like for
Yeah,
example,
no.
like Microsoft is infamous for asking like how to reverse a linked list and some other questions.
Yeah. So I know a lot of people who literally had no coding experience and they just grinded lead code for like 2 months, 3 months, right? For like a big interview, and they land a job at like Facebook, right? So I would just do that lead code grind. Um, if you just want the job, just keep grinding lead codes. I think at my peak, so like when I was actually interviewing, I used to do 10 lead code questions a day for like 2 months. Actually, no, that sounds way too crazy. It was probably like 2 weeks, but it felt like 2 months.
That still would feel like a lot.
Yeah, it was like 10 lead codes a day for 2 weeks, and then it started dying down.
Yes. Stuff fun. I always find it really tough to do the code questions because they're not like interesting. It's mostly just like implementation, right?
Kind
It's
of.
like
Some of them.
yeah, some of them are better. Like I like the do you know like the raindrops one? Like the raindrops in the city. I like that.
Do you remember that one question we did with the tree?
Oh,
And you're
the
like,
tree.
oh, easy.
I got that in an interview. Oh my god, I got. There's this one question that's really funny. And so for a while I was living with Michael. Like we had a house in like last year, and literally Michael shows me this leak code question, and I can't get it immediately. Like I try for like 5 minutes and I can't get it immediately. So I'm like, you know what? I'll do this later. You know, because I'm gonna do another thing with the person. So I'm gonna go. I'll do this other thing and I'll come back. And then I kid you not, I go. I apply to some jobs. I get this interview. I think it was with oh, what company was it? It was another hedge fund. I don't even know. It was from some random company, and literally that's the first question they asked me. And I was like, "You're kidding? You're kidding me!" So I got it, but it took me like over half an hour to come up with a solution. It was bad.
Yeah. So companies normally just grab from lead code.
Yeah. So if you know those questions, it'll be good.
Yeah.
Okay. I think that's all my advice. Do you have anything else, Michael? Or should we shut this thing down?
Interview. It's like the common advice. So like when you do it, always like talk through
Oh,
like
actually,
what
no,
you
yeah, that can't be said enough.
right, and also don't like normally they give you like well at least for Google, right? They give you like a Google Docs, right? Don't just like spam it with like code and like ideas and stuff. You want to like structure it out because what ends up happening is they'll take this code or whatever you wrote and they'll send it off to like some committee or they'll look at it later, right? And they should be able to just like read your entire thought process through this like file that you send out, right?
Yeah.
So always just be clean. Always be clean. Always explain everything. Just structure everything.
Also,
Um,
my favorite advice is always even if you don't have like the optimal solution right away, it's okay if you give them like a suboptimal solution and just like talk through it. Like you can say like, well, the brute force would be this, and talk about the brute force and try and come up with something from there. Really, it's
yeah,
better than just like standing there in like silence the whole time. Like it's
and
good to
also,
like ask questions, show you can work through something, show you can like think about it more.
mhm. And also, if you don't know how to do it, that's totally fine too. Because I think my first interview, the amount of mistakes I made was like insane, right? But I just kept like asking questions, and it was kind of like a conversation between me and like the other engineer, right? And then we were able to like to work through the problem together, and just like showing that you can communicate as well is really important, right? Just being able
Yeah.
to work with someone to solve a problem, that's also really important.
I guess I feel like we've said this even before. Yeah, I forget if we said this in the intro in our intro thing or something. But like getting the right answer in a technical interview is like such a small part of like the actual what you're being sort of graded on, I guess.
Yeah. So I was doing mocks at Google, they were like, don't worry about like getting the right answer. I think what was more important was just having code
Yeah.
like on the page. Because what ends up happening is the guy interviewing you, right? He will assess you, he'll grade you based on like problem solving and everything else. And that code portion just gets reviewed by someone else. So just make sure you have code there so they know that you can write code,
Yeah.
right? So if they know you can write code by seeing this code, and then your interviewer will just give out like your grade. So just code at least.
We'll also be prepared for many companies if you do like on-site or even if you do like phone interviews and things, there'll sometimes be more than like one person or one interview. Like I know for lots of them it can be even up to like 4 or 5 in a single day. So just be like mentally ready to do like a lot in one day.
Mm. Yeah, interview season is a big pain. I know a lot of people go through it and they're like, it's just a grind. It's literally just you do leak code 24/7
Yeah.
until you get a job. That's basically how software engineering works. You just when it's interview season, you just end up just doing leak code every day of your life, every hour of your life.
To be fair, I don't feel like I've succumbed to that yet, Michael, but I don't think my prep is much.
Oh, but that's because you're part of MCP.
That is true. That's because I got this. I was doing this already with MCP, so I get this hands-on stuff.
Me, I didn't have to do it either because I too was part of MCP. But for people not in MCP, it becomes their life, you know. But if you do it like with us, MCP, a bit every day, then you'll just get used to it.
It's a lot easier. It doesn't have to be like a scary, stressful thing you do just during interview season. And arguably, I think it's fun too. Like it's honestly like pretty fun. I'm honestly surprised there's a more popular thing seen that it pretty much guarantees you the ability to land a good job. It's honestly pretty fun. And there's like a bunch of like contests and things you can compete in.
Good networking too. I feel like everyone who has gone through MCP ends up at like some crazy company, right? So,
like I feel like we have a good track record so far, I guess, right? Like we sent a few people to Google, a few people to Microsoft, I think one to Facebook,
Amazon,
yeah, definitely Amazon.
Yeah.
And we'll see where we end up. Wait, you have your return offer for Google, right?
I don't want to say anything on live stream, but it's a maybe.
You have maybe. No information at all. Nothing disclosed.
It might be a maybe in the positive direction.
Ooh.
I haven't. Yeah, we'll see.
Nice.
Cool. 9:30.
I hope everybody enjoyed this. What?
9:30. You want to sign off?
Yeah, I think it's time to sign off. Thank you everybody for coming out. This is really fun.
I'm very hungry.
Me too.
What's the next event? What's the next event coming up?
I think it's we planned a data structures workshop. Although I'm debating after doing this if we want to split it into two. We can talk about that after. But we'll see. Yeah, Fengate.
I honestly feel like people would rather see C++ than Python.
Yeah.
That Python thing is a bit long. Yeah.
That's true.
C++ is actually kind of interesting. But we can do a poll or something.
For sure. Yeah. All right. In that case, peace out. I guess Michael's gonna eat dinner. I actually have my dinner here. It's been sitting here for like an hour. I'm gonna eat this thing too.
All right.
Peace out.